Hello, hello! How you guys doing today? Happy Wednesday night. Hope you guys got your coffee. I'm just topping off mine here. Alrighty. I love this mug. And yeah, sure, it's a winter Christmas mug, but it's huge. Like, here's a regular 12-ounce can. Here's the mug. Like, it's bigger than that, and then look at like circumference, diameter, size of it there. It's amazing. Such a good mug. Hope you guys brought your coffee. And hopefully you guys all got your Project 2 turned in. I just sent a reminder out to Discord to everybody. Don't forget, it's due now. Thanks for your flexibility with letting me push that one out 1 week. And let's take a look. I think we're doing pretty well. We're going to be on track. Got our schedule pulled up here. So we're going to cover Chapter 8 tonight, Arrays and Vectors, moving on to new material. And then we'll also talk about Project 3, our next project. And then coming up, we'll do pointers and have a quick little midterm, and then cover Chapter 11, work on project 4. So project 3 won't be quite so big. You've done some classes, so it'll be using arrays and vectors, just some practices with those, just to get you some familiarity with them before we use them later on. So because that one and the midterm are coming up, it definitely won't be quite, it won't be quite as large. So I'm not too worried there. And we'll work on the next project, and then you'll have lots of time for that final project. Again, about a month or so to work on that one. Due by the end of 12/16. So about, I can take it through 11:59 p.m., 1, 2 in the morning, I suppose, if we need it. But I've got about 24 hours after the final something is done to get grades in. They don't give me a lot of turnaround time, unfortunately. So that'll move somewhat quicker. I apologize, I've not yet graded all the project 1s. I was sick over the weekend, so didn't get anything done that I wanted to. Just kind of sat around all day long in bed. I slept like 12 hours straight one day, which is fantastic. All right, so I think what we'll do today, we'll start off with a solution to project 2. Then we'll jump into chapter 8, arrays and vectors, and then we'll talk about the next project, and that'll probably be our session for tonight. Any questions before I get going? Everyone get a chance to get their project 2s turned in okay? I forgot to look and see how many were turned in. It was not as many as I thought, unfortunately. You guys around in Twitch chat? Anybody? Let's see. I think I can see who's in chat. Some users? A couple people? Alright, cool. Cool. Let me throw out a poll here. I'll just ask how you're feeling. Bad, not good, okay, alright, and good. I don't know if alright is actually better than okay or not, but I feel like it is. So, hey, thanks for responding there. A couple folks are around, thanks. It's real lonely to just sit here and talk to my computer, so I like when people chat back and forth, because I do miss being in person. Not enough to do a Zoom call where I have to pester everyone to turn on their webcams and all that annoying stuff, but I still fairly sold on Twitch being a good platform for this. If you guys want, again, we've got that voice channel in Discord. If you guys want to hop on and chat or talk to me, I can hop on that and make that work if you don't like typing in your questions. So, or we can always do something after. So we probably won't go right till 10 o'clock tonight. So we'll have time after if you want to hop on something. We can do Q&As there, but feel free to stop me anytime. Hey guys, thanks for saying hi in chat. Makes me feel less lonely. You guys brought your coffee? All right, so we got a couple people who are good, a couple people who are not good. I'm sorry about that, and a couple people who are just all right. No bads, which is good. I think bad is worse than not good in the rating system here. So is it something about project 2 didn't go well, or I don't know. We'll go over the solution tonight. I'll show you one approach that we might take here, and then we can move on to some new stuff. How's that feel? Cool. No objections, at least in chat. So let me start up a new project. So this is project 2. Oh, no, don't type it there. There we go, project 2. All right. And we'll create that in my folder here, my GitHub repository, to make sure Git can track it for me. Be nice and handy. And I've got the project definition here, right? So we're building a couple classes with unit tests. So we're doing the bank savings account, we're doing the money in your pocket, doing the market money investment account, and then the simulator itself, which will actually just do all of these looping things for us here. Okay, so I've got the rubric out. Again, sort of focus on the rubric and the definition. Hopefully the rubric comes from the definition, if that makes sense. Come on, Visual Studio, work with me here. Just thinking real hard about it. Okay, awesome. Let's go add our source file. So this one here is where we can do all of the input-output stuff, right, in our main. Here we don't want the class to be responsible for anything input-output, because then it won't be as reusable. And I know that's sort of a pipe dream, but that's the goal, that's the ideal, and that's what we're going to be working towards, is making our classes be just standalone, right? They shouldn't depend on console input and output. So we're going to include IOStream here, and then we'll, using namespace standard, and an int main, oops, and we can return a 0 when we're done. Just good practice, okay? So we're off to the races. So we need to define a couple of these things here, and let's come back to the definition. Maybe I can grab some of these here. So we need a bank savings account, we need a money in your pocket, we need a market money investment account, and then the simulator with a couple variables here. Why don't I grab all of this as a comment, and we'll throw this up here. Okay, and sure. All right, and then we're going to have money in your pocket. I don't know, pocket money. Money. And then we'll have bank savings account. Savings, and what do they call it? Market investment or something? Market investment. Investment. Right? And yeah, it doesn't know what any of these things are, right? Oops, no idea what these classes are. Okay, that's fine. We're going to go write them. So let's go make some header files. So let's make a, and again, I'm fond of one class per file. It's just my preference. It may or may not make some slight differences when it comes down to compiling and precompile headers and all that fancy C++ stuff. We're not going to get that deep into it here. We're more focused on the language at this point, but C++ can do some pretty crazy things, and it's really powerful. I just like putting them all in the H file, and then, sure, that's my preference. If you go get a job somewhere and they tell you not to do that, then you should do that thing that they say, and don't argue and say, oh Eric told me not to. Yeah, don't, right? This is for simplicity for class here, right? So that's a money in your pocket H file. Boom, done. And this is public. I'm sorry, a class money in your pocket. Right, great, we've got that. And again, we're using Pragma once because we're in Visual Studio. Otherwise, you have to do that if and def stuff. The book has all those examples. You're welcome to go find them there. We'll add another H file. This one was bank savings account. Savings account. And that was the bank savings account. Okay, so we got that one. And then we'll do one more. We'll do the market investment. Market investment. Class market investment. Okay, cool, we got those, and now I need to go do some includes. Remember, when we include, we're not using the braces anymore, we're doing quotes because it's our own project. Include quote. Nope, not that one again. There we go, and include. Remember, at this point, what that include is doing is essentially replacing this line with a copy-paste of everything in the H file. Sure, no problem, right? We're okay with that. Not going to be too concerned. We are going to need to probably use this namespace thing because otherwise it can cause some trouble later on, but that's okay. Right, we're not too concerned about it. Right, and now it's not erroring anymore here. Great. So we're not going this like fully test-driven development method, but maybe we could. I'm kind of trying to flush out what we're going to do here in main, and then we'll add the functionality to the classes as we go. So maybe as we define it here, we'll add a stub method, and then we can write a unit test for it, and then we can go finish it out. Does that make sense? So like as we're designing a solution, an object-oriented solution, can you guys see my hands? So I need to put them up here. Excuse me. We look for those nouns. Anything that's noun could be a class, right? These are, sure, I mean, you could call these nouns, right? Your savings account is a thing. Person, place, or thing. Market investment's a thing. Money in your pocket's a thing. Those are all nouns, and then all those nouns have attributes, right? So we've got a private section, we have a public section. I know by default things are private, so technically you don't need that there, but I'm a big fan of being explicit, right? I don't mind typing one extra line here to remind me or whoever else is going to read my code that yes, I know that's a private section, right? Sure, relying on convention is great, that we know that's what it is, but okay, that's fine. So public and private sections here. So what we're going to do is we're going to ask them how old they are and how old they want to be when they retire. So we'll have an int for current age. and an int for desired retirement age, and we can ask them, right? How old are you now? And an end line probably, and then we can see in our current age. And then we can output, how old do you to be when you retire, or what age do you want to retire at, maybe, is a better question. What age do you retire at? Right, depending on when you were born, the age you qualify for Social Security, which is just a portion of your retirement funding, should not be the only sole funds you rely on in retirement. It was never designed for that. So like when people tell you and feel bad that seniors are only getting, you know, $600 a month from Social Security or whatever, know that it was not designed to be their only income. And that doesn't take away from the fact that it is their only income for a lot of them, but it was not meant to be that way. Just keep that in your back pocket. And we'll see in their desired retirement age. Cool, so now I've got those two things, right? So we've got those, how old they are, we need to get current balance. So let's get some current balances. So we'll have an int probably. I mean, they might go down to the penny, but sure, why not? We'll do a double. This will be, I don't know, balance. And we can see out how much money do you have in your pocket. Right, and then we can see in balance. Now, I don't mind reusing this variable. If you want to have one variable for each as a starting balance, that's perfectly fine. It's going to take up a little bit more memory, but 3 doubles versus 1 double, we could care less at this point. Memory is cheap as far as we're considered, so we're not going to mind one or the other. That's, you know, the hat surprisingly makes it warm. I guess I lose a lot of heat off my head. So when I have the hat on, I get really warm here in my little cave of an office. I say cave because it's actually like this old loft bed that my son used to have. And he wanted to get rid of it once he started waking up and hitting his head on the ceiling, once he got big enough. It was not as cool. So, and it's a nice little built-in desk here. So it's now my desk. All right, so we'll get the balance, and then I need to set that pocket money. So I've got like pocket money dot, I don't know, are we going to set money or add money, or we have to decide what we want to do with pocket money. So what did we say here in the definition? We said we should be able to add money or withdraw money. So there's no sets, right? So we're going to be able to add. So let's add some money. Pocket money dot add, and we'll add the balance. Right, that's my starting balance. Great. Oh, it complains. There's no method for add. Oh, bummer. Okay. Well, let's go over to pocket money. Money in your pocket. Let's add a public method. It's probably void. I'm probably not going to return anything. We'll call it add, a double for money to add. And again, we're just going to stub things out here. We're not actually going to finish them, right? We were going to finish them later. So there's nothing we're going to do for a void method. We'll come back here and fix this later. You can even add it to do. Sure, fix me later if you want. But that way I've got the method here, and now it's not complaining. No functionality yet. We'll go and write our unit tests in a little bit to make sure we do the thing we're supposed to do. Okay? And then we can redo this. And maybe, I don't know, maybe those all are related, so let's do it again. So I don't need to redeclare balance, right? I already have a balance. I'm going to say in your bank savings. We'll input balance, and we'll take our bank savings now, or our savings dot add the balance. And it says, oh, I don't have an add method for that. Okay, so let's go to the bank savings account. You know what? I'll just copy off of this one. Right, and that fits the definition, or bank savings. We should be able to add money, take money out. We haven't got to that interest rate yet thing, but that's okay. We'll get there later. Okay, so we got that one, and then we'll do it again for our market investments. In your investments. All right, we'll input balance, and we'll take our investments, and we'll add to that. And again, that one doesn't have an add, that's fine. Let's go copy paste it. Add, we'll go to investments, we'll add it in, so I can add some money. And that all fits right with our definition. We should be able to add money to each of these. Add money, add money. Great. We okay so far? All right, so we're following along. So now we have our initial balance, done. Okay. Then, oops, sorry. Okay, good. I have my webcam over where all these alerts show up. I should make my phone not pop up on my computer. You don't want to see my text messages, do you? All right, and my phone is on mute. Good. Or vibrate at least. All right, so now for every year until they retire, we need a loop. We're going to apply this investment or interest rate to the accounts. We're going to print the current balance and ask if they want additional savings or withdrawals, right? Ask them what they want to do. Take money out, put money in. Hopefully you're putting money away because that's your like savings for retirement. But you know, sometimes you take money out. We're simulating it, sure. And then once we get the end of the loop, we'll do this thing. Sure, so we're ready to loop. So we're going to loop now. So I want to say for int year 0, year is less than my desired retirement age minus my current age. Sure, we can do some arithmetic there. Why not? Year plus plus. You know, there's probably nothing wrong with actually changing current age either, looping from current age until current age is less than this. You know, let's do that. That's probably easier. So we'll do that. So we don't need to declare anything, right? Remember that is optional in a for loop. Kind of crazy looking, but you don't have to. We're going to say, well, current age is less than or equal to, right? Because you at your retirement age, no, we'll do less than. Desired retirement age, we'll take current age plus plus. Okay, so that first portion, there was nothing for us to declare, totally optional. We could also do it as a while loop, right? We could say while current age is less than and stick this current age somewhere in the loop, the while loop. That's fine too, right? I'd like fors, but this syntax is a little funny here with no declaration, but that's okay. No reason to make a stop. Okay, so now we need to ask them, right? For every year, that's our loop here, we're going to apply those return on investments or interest rates. Okay, so what did we call it? We said for our bank savings, oh, I didn't even give you a name for a function here. So sure, let's what do you want to call it? We'll say my bank savings account, nope, savings dot apply interest or earn interest or what? Apply return on investment. Why not? That's a nice, lovely, long method name. And we'll do it the same for our investments. Investments, apply return on investment. Investment. That way the method names match there, right? I think I did the same typing. Yep. And I can add that same method to both of them. So the money in your pocket never earns interest, right? Because it's in your pocket. So, oops, void. Apply return on investment. Doesn't need any arguments, probably. Right? So a void method we're just stubbing, not actually going to do anything. We're just putting the here's a placeholder, right? And we will to do actually write this thing, right? To do fix me. I mean, you know, you could write something else in there if you wanted, but that's okay. All right. So that's our loop. We're applied the return on investment. Boom, done. Print the balance in each type. Okay. So let's print out a balance. So we can see out balance of money in your pocket, or I don't know, I mean, any way you want to do this, right? You can balance, add an end line, and we can organize this, right? You know, money in your pocket. We'll take the pocket money, and then we need some sort of way of getting the balance, so probably a get balance method, right? Probably put a $sign in here just to make it look pretty, and it says, oh, I don't have a get balance method. Okay, well, let's go add that. So that one is going to be a value returning method, right? It needs to return something. So for now, we're just going to return a 0, right? That's finishing out the stub here. I can return a 0. It's not the real number, but it's going to be a placeholder, because if I don't have a return statement on a method that returns something, a function that returns something, it's going to be a big fat red line for me. And I know I'm going to need this for each of these, so I'm just going to go add them in now. Okay, before I get all those red lines. There's money in your pocket, and we'll do money in your bank savings and money in your market investments. Okay, savings get balance and investments get balance. You okay so far? Just kind of go through, tackle these one at a time, right, as we go. So print the balance each type. Boom. Okay, now we're going to ask for additional savings or withdrawals from each account type. So we could ask for yes or no, or we could just ask how much you're adding or subtracting a negative number. I mean, I'm not too particular of which way you went about this. And I'm kind of partial to not asking yes or no and then a number. You're like savings or add money, you know, 1 for add or A for add or W for withdrawal or 2 for withdrawal or 3 for do nothing or N for nothing. And we could just say, hey, how much money are you adding? Or 0, right, for nothing, no change. So I think we're going to do that. So, and we can just reuse balance too. So I'm going to actually copy all of this because that's essentially what we're doing here. How much money do you want to add to your pocket? Right? How much money do you want to add to your bank savings? And how much money do you want to add to your investments? Right? And, you know, I don't know, negative for withdrawal. You can give us more prompts. So we know like negative add is a withdraw. Maybe. You know, that doesn't work actually with our withdrawal money needing to charge a fee. That's unfortunate. That's unfortunate. So maybe we'll have different functions. Okay, that's fine. We can even check, right? Add / withdraw. Withdraw. And maybe say negative. I don't know, does that make sense? Withdrawn, withdraw? Or maybe it's easier to just ask add or subtract at this point. Right, because then I can check if balance is less than 0, I'm going to subtract, else if balance is greater than 0, I'm going to add, that sort of thing. Right, pocket money dot withdraw. Oh, and withdraw balance. Maybe that should be amount. I don't know. Maybe balance is the wrong word there. Amount. I'm going to change that to amount because that's bothering me now. So we'll rename this to amount. So don't change each one individually because that's a big waste of your time. You want to go to rename here in the tool, and we'll call this amount. Is that 2 M's, 1 M? I can never remember. And it's going to say, hey, I'm going to go change it all these places. We say, great. Look at that. It changed it to amount. Okay. And we'll do the same thing here. So we'll add each of these checks. We'll add each of these checks. And then we need to change it for savings. Right, and change it for investments. Okay? That makes sense? So are we going to be withdrawing a negative? That's okay. Maybe we can just take the absolute value later if we know what that's going to be. That'll make sense. Yeah, we can just take an absolute value later. All right, so we need to add these withdrawal methods. So let's go and add a withdrawal method. And those are voids, right? Withdraw. Money to withdraw. Okay, great, we got a method. We'll add it to each of them. I'm just putting it kind of next to add because like it's add and subtract or add and withdraw, sort of just to have it make sense there. They can go anywhere. The order doesn't matter here. But now those red lines should go away. And then I don't have that add and I don't have that add. Cool. So now we're taking care of that. You guys all right so far? So now we're adding each year if they want to add or subtract for each account type. Boom. Once we get to retirement age, display the balances for each type. Okay. Well, if I'm going to do this more than once, let's pull it out. So I'm going to show you a trick. You can right click and you want to go to, where is it here? Where is it? Edit? Advanced. No. Oh my goodness. Refactor. There we go. Refactor extract method. So we want to pull this out to be a method. And this will be print balance. Uh-oh. It was unhappy about something. Right, remember if we have variables declared in main and we're having a different function, I can't get at those variables declared in main. And don't put things as static variables. That's just bad practice. So we're going to avoid that here. So I can just pass references. I'll pass a reference to each of those accounts. Where do they go here? Where'd it go? Oh my goodness. How old are you? Oh, right here, right here. Oh my goodness. Yeah, print balances. Perfect. It said I didn't like it, but I don't know why, because I think it was fine. Okay, so each one of these now is passed by reference. And I can call get balance and print out the balance details each time. So when this loop is done, right, we got to print balances again. We're going to print balances. Print balances. And you know what? I should just copy paste this line here. Trying to just cut out some of that white space, clean that up a little bit. Okay, that's not so bad. And is that it for balances? Yep, 1 through 2 strain age. All right, oh, then a grand total and adjusted for inflation. Okay, so let's print a grand total. So a double grand total savings is pocket money get balance. Oops. Plus my savings get balance. Plus my investments get balance. Right? That should be my grand total. We can print your total retirement savings. This is total savings, maybe a $sign. Oops. Just that one. There we go. Nope. Just total savings. There we go. And maybe an end line. Right, and then adjusted for inflation. So now we have a grand total adjusted for inflation is the grand total divided by, and let's see, we need to, I gotta look this up because I don't even remember, C++ power function. Yeah, POW, okay, there we go. Yep, POW. Functions of CMath, okay? So we gotta include CMath. And usually I like having mine down below and all the library ones up above, just a preference. So divided by, now we're going to take CMath, or it's just POW now at this point, right? POW, we're going to take 1.02 to the, and this was the number of years. So it's going to be retirement age, desired retirement age, minus the current age. Oh, we can't do that, can we? Bummer, 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 because we've been changing current age. That's going to introduce a bug. All right, so we got to calculate that first, right? So we'll have an int for years until retirement. Maybe if we calculate that first, right? There. Now I can use that value, having done that calculation, and my arithmetic won't screw up. Right, that's the adjusted for inflation value, oh, and a semicolon. Right, does that give us 1.02 to the power of years? Again, just assuming 2% is not exact. Inflation goes up and down, and depending on what they actually measure, but that's fine. So your retirement savings adjusted for inflation is grand total adjusted for inflation. I think that's it. Again, we haven't done anything in the classes yet, right? We have stubs, but like this is how we're going to interact with it. Right? We've got all that in here. Include source H. What did I do with source H? That's not what I wanted. Oh, that's why. Okay, that's dumb. No, don't do that. Let's delete that. And delete. Deleted. Okay, yeah, get rid of that include. We just need to go define it above. That's all. I'm going to be confused about where that is if it's not above. Yay, C++. Okay. There, I'm much happier with that. Much happier. All right, so this, we don't have any functionality yet, but we know how the classes are going to act. So I can do all of this and just have stubs, and this should run. It just won't do anything interesting. Right? Give me a bunch of zeros because we have no balances, but that's okay. Right? All right so far? Okay, so now we can actually go write some unit tests. Right, so I'm going to go to my solution. I'm going to go add a new project. I'm going to go find that test project type. Again, if you don't have Visual Studio and you're stuck on something else, I would take adding that in main beforehand as a bunch of testing, and then run the simulator with the checking expected whatever's. So no one asked me about that, so I'm assuming you either figured it out or you gave up on it. And I'm hoping you asked me, or you figured it out. I mean, and not gave up on it, because that would be sad. Oh, I forgot I gotta have Twitch Inspector open while that loads. See if I start dropping any. Oh yeah, it did drop a little bit. Oh, that's at the beginning of the stream. That should be okay. All right. So our test methods. Remember, two things we have to do now. We have to go add the reference to our project. So say, okay, I want to reference project 2. Great. Done. Then I need to go do these includes. So we're going to include, and this is still a relative path, but it's up a folder, so I need to go / project 2 bank savings, right? And we'll include the market investments. The market investment? Oh man, I should just do this /. There we go. Market investment.h and include, I guess copy paste there, didn't save any time. Project 2, money in your pocket. Okay, so I'm going to include all of them. You might have one test per thing as well if you're feeling particularly OCD. At this point, I'm happy with just throwing all the tests here for this project into one other test location here. I'm not too particular about that. All right, so we're going to test one at a time. So let's test the money in your pocket first. That one's easy. Money in your pocket. Here. Oh, you know what? Did we didn't set a fixed annual rate for interest, right? We need a function call for that. So we haven't gotten to that yet. That's okay. We'll add that feature in. And then when we talked about how we can fix this random value here, right? Either passing it a seed or some sort of thing there, right? We can fix it. We'll have to do that as well. So that's okay. We'll see that as we start running our unit tests, that we're missing a little bit of functionality, hopefully. All right, so money in your pocket. So we're going to do this AAA thing, right? We're going to arrange, then we're going to act, and then we're going to assert. Okay, so arranging, money in your pocket is really boring. You add money, you take money out, you get the balance. So we should be able to test that adding will change the balance and withdrawal will change the balance. And usually you want to test like one function at a time, right? Although getting balance we have to do for these other ones, so I'm fine for like one test for add and one test for withdraw. And now we didn't have any sanity checking in here, and I didn't ask you guys to, that if you try and withdraw more money than you have, something bad should have happened. Again, we don't really know how to deal with bad things because we haven't talked about exceptions yet. I think we get there, when do we get there? Yeah, in week 14 we'll learn the right way to do that. So don't sweat it right now. We'll get to the proper way for changing that. But now I can write a unit test, right? So let's test money in your pocket add, and we'll also do money in your pocket withdraw. Withdraw. All right, so the first thing we're going to do when we arrange is we're going to make a new money in your pocket. Your pocket is pocket money. Okay, and then I can take pocket money, and I can call, money. I can call add, pocket money. Oops, pocket money. There we go, add. And I don't know, let's have a, I'm sorry, that should be, that's our act here. That is actually acting, so we'll arrange, we have an, I don't know, a double for expected money. I will say, I don't know, $42 or $4.2 because it's a double, right? Why not? We'll add the expected money, and then we'll get the actual money back out. We'll have a double for actual money is my pocket money, dot get balance. And then I'm going to assert R equal the expected, right, my expected money, and the actual money. Okay, so we're saying this is what I expect to get back out. Computer, please check and match and make sure that it gives me what you'd expect. And we'll do the same thing for withdrawing money. Oops, I copied too much. There we go. So if we start with 0 and we withdraw money, we kind of want to get negative, but I feel like that's bad. So let's add a bunch of money, right? So I'll have a money to add is, let's add like $10, and then we'll have a double money to withdraw equals, I don't know, let's take out $4.02, 20 cents, and then we'll have the expected money, expected balance. Right, so that's money to add minus money to withdraw. Right, we can do that arithmetic. So we'll add the money to add, we'll get the actual money, and then we'll have an expected balance. Oh, that's a terrible variable name. I want that to be actual balance now. Actual balance. So that's what we're actually checking, not money, it's balance. Okay, renamed it there. Oh, I'm going to go rename it here. It's only 2 places, so I can change it 2 places. We feeling okay? So let's try it. And they should fail, right? If we did everything right. Because that's the funny thing, we actually want them to fail right now. So we can run tests while I grab some coffee. Because what we're doing is we're trying to write the tests to program in that expected behavior, and then I can write the classes, finish out all those methods, all my functions to actually do what I'm expecting it to do. Maybe? Is it doing anything? I think it's doing something. It froze, so maybe it's doing something. I might be thinking about it. I think I'm supposed to build my solution first. Let's give it another minute before I decide it actually crashed or not. Maybe. Alright, we broke Visual Studio. Did I really break it? Oh man. No? Thinks it's there. Let me open up another one, see if I can do that. I made it unhappy. That's unfortunate. If I can close that one. It's trying. Just hoping I don't need to reboot. The good old reboot. Let's see. What? Okay. Sure, I'll say okay. That's probably fine. I didn't actually read the whole thing. Project 2. What is going on here? Save, 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 save. Okay, it came back. Came back. Reload. Oh man. It is having trouble. It's one of those days. One of those days. Okay. I think we've got it all. Hopefully it's still there. Maybe it's still there. Okay, good, 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 good. We have stuff. So let me just try and build real fast and make sure that build step works. Maybe I'll take it a little slower. The computer is obviously not as much coffee as I have. But if I try and pour coffee on my computer, it'll probably make it work less good. Is that the technical term, work less good? Something? Okay, build succeeded. Now let's check out our test explorer. Let's try this again. Let me pin it here. See? Oh, it's thinking. It's thinking. Yes, coffee, exactly. That's right. Oh yes, there's tests. It sees some tests. Let's run them. Let's run those tests. Oh, I thought I quit that. Sorry. We don't need those messages. And they should fail, right? Because we're not actually doing anything. So if we're expecting balances, perfect, they failed. That's the only time you're excited that they fail, right? Yay! Okay, so now we can go finish that code. Right, we'll come back to the money in your pocket here, and let's do something. So if we're going to be tracking a balance, we probably need some sort of value for balance, right? A double for balance. Now, some people like putting this in here. I think this is terrible. Please don't do this, right? Don't set anything there, right? What you do is you write a constructor, right? You write a money in your pocket constructor, and we can even, use that cool notation and say balance 0 if you so prefer, so like. Right? Make the constructor set the variables. The constructor's job is to give good values, good defaults to all of your private data members. It's constructing an instance of the class. That's what it's supposed to do. So make the constructor do it. Sure, that's the same, right, as saying balance equals 0. Right? Same as above. Right? You guys got that picture? Do one more comment in case you want to take that one out. All right, so then add. Let's take balance plus equals money to add. And withdraw, let's do this. Let's include CMath. And we said because we might give a negative number here, and some people might give positive, they might be confused about what it should be, but they're calling withdraw, so we know we want to take money out. We're going to take the absolute value, so we'll say money to withdraw is fabs, and I don't know why it's fabs. Someone told me at one point what it was, and it's not abs for absolute value. We can Google that. So C++ abs versus fabs. Look at that. It's a common thing. It was even a search suggestion. Aha! Fab supports doubles and floats. Well, that makes a lot of sense. I like that. I am happy with that. That sounds like a good solution. Okay, so we'll absolute value that, and then we'll balance minus equals the money to withdraw. Again, we're not doing any sanity checking to make sure like you can't go negative. And banks actually love when you do that. They make all sorts of money off of fees for charging you money because they let you spend more money than you had when they could have just said no. And that, like, okay. Banks make way too much money off of fees. It's pretty sad. And then get balance should return balance. And I think that's all we need to do. Should we try it? Let's go back to our tests and let's run the tests. Now at this point, hopefully you're thinking, I don't know if fabs actually works because I'm giving it a positive number. Maybe we should test giving it a negative number. And I like the way you're thinking. Let's try it. Let's try also subtracting a negative number. That's a fine extra unit test. I didn't expect you guys to do anything like that. And again, I don't know how you handled it, but that's okay. Uh-oh. Oh dear. We had a unit test not work. If you don't ever withdraw the money, the balance stays the same. Imagine that. So we'll take pocket money, withdraw, money to withdraw. Look at that. Maybe that'll fix our unit test there. What do you think? Think that'll fix the test? Let's try it. Try actually taking money out. Come on. Work with me. Work with me. It's one little test. Yay, it worked. Okay, and then we'll write it one more test. Again, we're just going to copy paste everything here. Draw negative number. Negative number. And again, you want these names to be nice and meaningful and descriptive because as soon as they fail, you want to know what went wrong without having to go look much farther. So I'll say that's a negative 4.2 withdraw. And it should give us the same result. Right, so let's run our tests. And let's take a peek, see if that works. I'm going to drink some coffee while Visual Studio takes its sweet time. Uh-oh. Failed. Expected 14.2. Actually, oh, our arithmetic is wrong. Oh my goodness. I subtracted a negative number, and subtracting a negative number gives you a positive number. Can I just cheat and add? Right? Let's just do that, and I'll be happy with that. And let's run that test. Look at that. I'm running more trouble with my tests than I do my actual code. Okay, now it passed. Awesome. So now we should feel pretty good that Pocket Money does what it's supposed to do, right? Inside of our actual program. You with me so far? So we've got tests for Pocket Money. Boom. Feeling good about it, right? All right, how about bank savings? Should we do that one next? So bank savings, right, was supposed to have, let's come back to here, a add money, withdraw money. We also had that return on investment. So that should be a fixed annual rate set via a function call. Okay, so we need additional information then if we're going to be applying that return on investment. Right, you're head nodding, right? We're good with that. So let's take a look at our class here for money bank savings account. So it also needs a double for balance and probably a double for interest rate. Okay, so we should have a constructor for it. Bank savings account constructor. Probably takes what, a double for balance? Oh no, I'm sorry, no, nothing, right? We can just set them to 0. So balance is 0. 0 and interest rate 0 for now. Okay, we'll set those to zeros, and then we need to add a method for set interest rate. Interest rate. Is it interest rate? Return on investment? Sure, whatever. Double interest rate. And we'll set my this interest rate. I'm sorry, this arrow interest rate to the interest rate you gave me. Right, make sure I'm getting the right, my instance variable, not the argument here. And I guess we might as well have a double for get interest rate, right? Interest rate. That returns the interest rate. Cool. Oh, look at that. I'm already writing too much code here. That's okay. That is okay. The testing sets and gets is really boring. We're supposed to do it, so sure. So let's check withdraw. Sure. We even test withdraw negative. Why not? So this is bank savings. Add. And bank savings withdraw. And bank savings withdraw negative. Why not? Why not support that? Right? Because the code we are going to deal with. Right? Test meme star. I don't know what. Sorry, I'm not following Joseph. All right. So I think we're good there. We got a couple tests. We're going to need some more in a little bit. Right? So we're going to also test that apply return on investment. Oh, as a link to Reddit. Oh, you can post it in the Discord. I set the channel auto mod settings to not like links and stuff, just to make sure people don't spam us with junk. All right, so we're going to test a interest rate. That'll be like a set and get test, and then a testing for apply return on investment. Savings, apply return on investment. Okay. Bank savings, interest rate, bank savings withdraw, savings withdraw. Yep, okay, cool. So we got some tests. Let's actually go make sure we're doing the right thing here. So this is a bank savings account. Call it savings. We'll add some money. Withdraw some money. Oh, where do we start here? Bank savings. Oh, it's money in your pocket. Withdraw. Oh, I changed the wrong one. Changed the wrong one. Here we go. Bank savings account add, right? 1, 2, 3. Yeah, bank savings account add. Okay, so this is bank savings. Call it savings. Have an expected money. We'll add the money. Get the balance back out. Oh, it's a bank savings account. There we go. Get the balance. Expect they're the same. All right, awesome. So I can just rename this one here. Bank savings. Add some money. Withdraw some money. Check that they match. Good. That's a bank savings account again. Add a negative. Make sure it works. Okay. Savings interest rate. Okay, so now this one is going to be a little bit different. So we don't actually care about the expected money. We're not going to add any money. We're not going to check the balance here. Okay, bank savings account. Call it savings. This is going to be an expected interest rate and an actual interest rate. Interest rate. Okay, so we have the double expected interest rate. Interest rate. Say, I don't know, 0.02. Like 2%, it would be phenomenal because then you're keeping up with inflation. I think 1% might be a little more realistic at this point, but sure. So we're going to call savings.set interest rate as the expected interest rate. Come on, I'll just copy paste. When all else fails, copy paste. And then a double actual interest rate equals my savings.get interest rate. Okay, and make sure they match. Cool. We're going to do the same thing here, but we're not going to check that one because we need to set the interest rate, and then we're going to add some money. So we'll have a double money to add, say $100 is probably the easiest way to check that, right? We'll set the interest rate, we'll add some money, add the money to add, and then we'll have savings.get, apply return on investment. Should take that interest rate and add that much money to us, and then we'll have an actual balance of get balance. And we'll check our expected balance. We'll have a double for expected balance. And that should be what the money to add times, plus the money to add times the expected interest rate. Right? Take your balance, add the interest rate that you earned, apply to your balance. Okay, so we'll have an expected balance and an actual balance. We okay so far? And now all of those should fail, right? We want failures, because we want it not to work because we haven't actually written any code yet. The set interest rate, actually we did, I'm sorry. I wrote a little bit of code. I got excited. The sets and gets. You know, those are real basic. So I'm not feeling too bad about that. Yep, so the interest rate worked, the other ones failed. Awesome. Isn't it weird that we're excited it failed? I don't know, it always seems weird to me. So for add, right, I did this already over here. I don't need to go reinvent the wheel. So I'm going to copy paste add and withdraw here. And yes, there are better ways to do this, but we haven't done it yet, so don't worry about it. So we add and withdraw, including negatives, right? Interest rates, great. And then the apply return on investment. We'll take our balance plus equals the balance times the interest rate. Okay. Now you might be thinking to yourself, this set interest rate should probably do some sanity checking, right? What if someone gives me 2 instead of 0.02 because they mean 2%? Well, you know, it's a little difficult to do that just taking values in here. So like I can check it, but maybe you found an account that gives you 200% interest, and maybe that's a valid value. Now I'm going to call BS on that and tell you you probably fell into some sort of Ponzi scheme if they are claiming 200% return on investment, because that just doesn't happen. But you know, if we do need to support that sort of thing, right, we've got some options. So maybe we do some sanity checking and we check, hey, if it's greater than 1, maybe we need to divide by 100. Totally optional. I didn't expect you guys to do this, but you know, we're just going to try it here. So if the interest rate is greater than 1, or maybe greater than or equal to 1, we'll take interest rate divided by 100. Because you probably meant 1 for 1%, 2 for 2%, like a whole number, that sort of thing. Okay? And then we'll set it. Just to do a little bit of sanity checking, right? We'll be okay. Right, and then balance should actually return the real balance. There we go. Now let's check our tests. Let's go run our tests. You guys having fun with this yet? I actually find this test-driven development super satisfying because like you get these red X's and then you get green check marks, and like you're really focused in on this is what I need to get done. Hopefully you guys actually have fun with coding and writing programs and stuff, and you think of, oh, wouldn't it be cool if it did this, or wouldn't it be cool if it did this? But what test-driven development helps you focus on is this is the spec that I need to meet. I know it must do A, B, C, D, E, F. So I'm going to turn those red checks into green, or red X's into green checks. Okay? And just a tidbit here, make sure if for being aware of people who are colorblind, it's nice they have a different symbol, not just a color. Use the combination of both. I've got a colorblind coworker who hates applications that aren't designed well like that. So just a tidbit there. Cool, so this one seems to be working, right? We took care of the easy ones first, right? We did bank savings, we did money in your pocket. Now we have this market money, which has a variable number here, and this one is tricky, right? Okay, that's all right. We can deal with that. We can deal with tricky. Okay. So our add and withdraw are mostly the same. Not quite. I don't know if we can copy paste because they're not quite identical. Add is the same. Right? We weren't charging fees on adding, so let's come to. Oh, we should write the unit tests first, right? So I think we have all these same ones. Entry-level programming projects, like learning how to code, there's a couple, not as common that I know of. Most of the ones that I know of are like these silly algorithms solving puzzles, which is more like our data structures class. They have more examples and puzzles like that. Yeah, I'm not sure of any other good, like, hey, try a basic thing. Like the book has a bunch of projects at the end of every chapter. He's like, hey, try this, try this, try this, try this. And I think I have access to the code for those two. I don't know, I never use the book ones because people post stuff like that on Chegg and Course Hero and other terrible websites that should be shut down, but that's okay. All right. So now we're going to do some unit tests for our market money. So I'm going to take all of our bank savings and we're going to copy all these. I don't need the interest rate one though, so I'll take that one out in a minute. I don't know if you noticed that you got this green line here and a yellow line here in Visual Studio. So yellow means it's new since you've saved last. Green means it's the same. So like you can quickly just at a visual see where you put new changes in. That's sort of how I'm going so fast through here. This is investment, market money, market investment, add. And you know what, I'm gonna do a little market investment. Is it S? Investment? I gotta open that one up. Market investment. Yep, okay. So I'm gonna do a little find and replace, and that may or may not work well for me. So I'm gonna try and find bank savings, and I'm gonna replace that with market investment. Oh, it's gonna get account though. That's all right. So I'll do bank savings account first. Savings account, and I know I want to start here, so I can do one or two at a time. So let's do that one, and that one, and that one. I'm still in the yellow. Still in the yellow. Okay, now I'm done. Now I'll come back into my yellow section. Now I'm going to replace these ones, bank savings, with market investment again. Okay, let's try that. So I want to replace the next one, the next one, the next one, the next one, just to put the right names in here. Perfect. Okay. So now this one is failing where I had setting interest rate. I don't even need this test at all because we don't set anything. Right? There's no setting of the interest rates. Okay, and we're not going to set interest rates here. Okay, so all the other basic ones here for adding money should work. Withdrawing money needs to change because every time we withdraw, we need to charge a fee. Right? We said there's a $10 fee every time we withdraw money. Okay, so we're going to need to take that into account. So we probably want to add maybe $100 to start, and then minus 10 for the fee. Or maybe we'll say a double withdraw fee. Withdraw. Is it a withdrawal at that point or withdraw fee? I'll say 10 here, and we'll subtract that withdraw fee. Make sure that one matches. And we'll do the same with our negatives here. Okay, so hopefully those ones will work. Not too many changes needed there. But then the apply return on this one. This is where it's going to get tricky for us, and that's okay. We'll deal with that when we get there. So let's run our tests and make sure they fail. Okay, we don't have any code written yet for our market investments, and that's okay. Oh, I ran all. It shouldn't. I mean, once they start running, it should be fast. Okay, so market investment fails, 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 fails. Those look good, right? We want them to fail, which is weird, but that's okay. Satisfying. So let's go to the market investments and let's actually write some code. So adding should be the same, right? I'm just going to steal that add because that's a one-liner. I guess that's silly. Oh, it needs a private double for balance. Right, so we can track that balance. And then we should have a constructor. Right, so we're going to make our constructor, market investment. We'll set balance to 0. Okay, and then add, we'll take balance plus equals the money to add. Not plus plus, plus equals money to add. There we go. And withdraw, again, let's steal this fabs thing here, and then we'll also withdraw $10. Money to withdraw. And now, a couple options here. Now, this is where, if you've had a chance to actually read the chapter in the book, they used a couple things that are static versus instance variables. So these are all instance variables. They belong to each instance of market investment. But what we want to do is we really want each one is always charges the exact same fee. So if I had something like a double withdraw fee here, withdrawal fee, I don't know. Each instance of market investment would have its own fee that needs to be stored in memory. Right? So that's not I mean, that's really a waste of memory if they are all the same. Does that make sense? Like, we don't want them to be all the same here. So what we want is we want it to be a static level, which if we declare it as static here, so static means it's set once for the entire class definition. Definition. Okay? And now that one here, you know, we can put equals 10 because we're setting it. Oh, is it not letting me do that? Oh, that's right. Static constant double 10. Now is it happy? No. What did we do wrong here? Constant. Is it backwards? Constant static? I can never remember. I might have to just go Google it here. Constant double. I have an in-class initializer. All right, let's just go Google it. C++ static constant. Sure. Let's see what I did wrong here. Oh, we could probably also find it in the book here. Yeah, static, it's shared. What did we do wrong here? At the class level. Static constant int. What did we do wrong? Oh, as a namespace? That's silly. That's alright. Static int. Alright, let's I don't know. Let's maybe we'll just take the constant out. We'll just let it be. Was it still mad about that? Static double? It was still mad about that, wasn't it? That means it's set once for the entire class definition. Yeah. Why is it so mad here? Do I have to put that in public? Aha! Nope. Oh, it's still mad at me here. Shoot, remember with an in-class initializer must be constant. Constant double can't have an in-class initializer. Well, that's not what we want. That's weird. That is weird. All right, maybe I didn't do good enough Googling here. Inline. Oh, geez. Okay. All this to try and make it easier here with the static. That is obnoxious. All right, and why is it not? Okay. Withdrawal fee, I can't set it to 10? No. I put it up here? It's got to go somewhere, right? Nope. Still not. All right, forget it. Forget it. I am just upset, and we'll just set it here, and I'll feel bad about it, but that's okay. We'll withdraw fee. Withdrawal fee. Withdrawal fee is 10, and sure, we'll just set it. Okay. That was way too much time to do that. Sorry, withdraw fee. We'll also charge the fee. Okay, so we'll take the withdrawal fee, subtract it from the balance. I'll have to double, I think you have to do this crazy, like adding in other places here. That's really annoying. Yeah, these inline versions. That's fine, that's fine. Okay, it's gonna bother me for a while now, that's okay. So we got our market investment. All right, we can add, we can withdraw. This apply return on investment now is the problem because we need to do random stuff. Right, and we had a couple options. Right, we said maybe passing in a random seed might be a good option here. So we're gonna do our include C standard lib, right, and include, oops, that was not in quotes. It should be C standard lib. No, that one. And was it C time? Was it C time? I want to say C time. You know, let me just go Google that one too. Or actually, we can look that one up. Right, we've done this one before. 2252, and let's take a peek. look up random. See where we used it before in the repository. Look at that, we even tested this random thing here. Random. That's in the wrong class. Come on, come on, come on, come on, come on, come on. I was in bottle there, right? Okay, time, ctime, and c. I was right. Ctime and cstandard_lib. Yep. So we would take a bottle that would seed a particular value here. All right. So we'll take a market investment here, and we can have an int for seed, and you can actually use it like an optional thing here if you want. An optional argument. Like you don't have to go this route where you don't define it and you pass it in. Right? Actually, maybe we don't want 0. Because we want time of 0. Maybe that's why. Time of 0. Can we do that? Sure. And then we'll call srand. We're going to seed random and give it the seed value. So if you give me a seed, I'll take it. If not, I'm going to take whatever time of 0 is. Then I can actually go do this random thing. Let's grab our random code. Where's the random? Random. Come on. There we go. Rand mod something. Right. Okay. So if we're going to apply the return on investment, we said it was 4% plus or minus 6. So I need a value that will be from -6 to +6 here. And to make that make life easier, I know if I just shift everything by 6, that's 0 to 12 minus 6. So if 0 to 12 are my possible values here, I need the, we'll just call this the double random return. Adjustment is rand mod 13, because then I'll get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, not 13. Right? So 0 through 12 are valid values. Oh, that should be int, sorry. And then we said the actual return on investment then. Int actual return on investment is 4 minus, and now this is 0 to 12, so we're going to take that minus 6. Or we just, just minus 6 right here. We'll just do that. Minus 6 right there. And actually, I'm sorry, we're adding, right? Because it's positive or negative when we subtract the 6 here. If I would have done the subtraction over here, I could have... No, it was still subtract was wrong. So this is our actual return on investment, right? This is a whole number. So maybe we should make that a double, right? An integer plus an integer. Random's giving me an integer. And then we can take that actual return on investment, right? Or divide it by 100. Let's force that. Let's do that first, right? 4 plus or minus this number, and then divide that by 100 should be our actual return on investment. And then we can go steal this line here and change the balance times the actual return on investment. Now we could have stuck this whole thing in here, right, in one spot here. The reason it's nice to have a separate variable for it is when I'm doing this in debug mode, I can actually watch it and see, right? Like I can see what that value is. Does that make sense? Because otherwise it just calculates it and I never get a chance to see what that value is. I only see the actual return on investment. So this lets me break it down step by step. It's just for me. And there's no reason not to have it. All right, and we'll have balance. Okay, and let's take a peek. Can we run some unit tests? Now, the random one's not going to pass, right? Applying return on investment, because it's not 2%, and the odds of it hitting 2% are probably pretty low. But what we're going to do is we're going to send it a seed value, then we're going to look at what the actual result is, and then we can plug that in as our expected result. We can cheat a little bit here. Whoops, withdrawing money. That's right, we forgot our actual fee there as well, minus the withdrawal fee. So let's add, say, $100 there. Withdraw, money to withdraw minus the withdrawal fee. Subtract, withdrawing a negative number. No, we want to add the negative number there, don't we? And then subtract the withdrawal fee. Is that what we did wrong? And then the return on investment. Okay, probably just typoed that one. let's try that one. That's withdraw a negative number. Because it was, yeah, it went up instead of down. So let's try that one again. Maybe we did someone else wrong there. We'll see. Oh yeah, both withdrawals failed. That's not good. That one withdrawal failed too. So 100 minus 4.2 minus 10. It should be subtracting. Oh, it's not savings. Oh, we called it savings. That's fine. We should rename that one. Let's see, it's still failing. So what did it give us? What did it give us? Run that one. Expected 85, we went up by 5.8. How did they go up by 5.8? We must have done some arithmetic wrong. That's okay. So let's take a peek. And this is why it's good, right? We did something wrong in here when we withdrew money. Minus the money withdraw, minus the withdrawal fee. Oh, if we take away 10 from that, we want to add that in, don't we? Right? We want to do the money to withdraw as a positive plus that, and then subtract. And we did have an arithmetic issue. Look at that. So our unit test caught a bug. Amazing. That's what it's supposed to do. Okay. Now I'm feeling more confident that'll work. Let's give it a try. That should go down instead of up. Maybe, maybe, maybe. Yeah, that one passes. All right, let's try with a negative number. You guys are awfully quiet there in chat. Is it going okay still? All right, now this is where it failed. We expected something, we got actually something else. So now let's go change this. So now when we make a market investment, and I'm going to change that to lowercase market investment. That's going to bother me. Savings, savings, savings. All right, we've got to replace that a bunch of places now. So let's go up to our market tests. Savings here, money, market money. So let's do a find and replace. Let's find savings and replace it with market investment, lowercase. Replace that one, 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 and we're done. Cool. I'm a little happier now. Not too embarrassed. Right, anyway, so we're going to have to seed this with a value. So let's give it 0 as a seed. I mean, you pick any number you want here, right? It should be fine. Sure, seed it with 42. Now we're going to see what we get back out. Because I don't know what it is yet. I don't know what that random seed value is going to be. But let's see what we get. We're just cheating here. There's other ways to do it, but we need more stuff about classes that we haven't learned about yet. So don't worry too much about it yet. There's other ways. Okay, so we actually got 100. We added 100. Oh, that's expected interest rate is wrong. So we'll just have an expected value. We add some money, and we apply the return on investment. We get the balance out. All right, so the expected balance should be, I don't know, what did it say it was? 100. That doesn't seem right. I'm just going to put a 101 in here for now, but let's put a breakpoint in here. This is the other amazing thing we can do. We can see what happens when this code runs. So we're going to debug our test. And we're going to see what we get with that random seed. Just thinking about it. Maybe. Maybe. Debug tests? No? Where's my debug? Debug tests. Okay. Maybe I have to click in the right spot. That looks more like the debugger. Okay, cool. So now we've got our market investment. Fantastic. So let's step in, make sure we can check on our code here. Okay, so we're going to see what we get. So random mod 13 minus 6 gives us a 0. That's not a very interesting value to get there. Why did we get, okay, maybe we just got an actual 0 here. So let's try a different seed value and see if we get a different result, because 0 is really boring, and I don't want a 0, right? I want to actually make sure it is changing somewhere. So let's try 1,000. I don't know. We'll make up a number. and I'll try and debug it again. Excuse me. Nope, I want to debug. Shoot. That was wrong. Oh, it's taking its sweet time. Okay, let's debug. I don't actually know what the expected is supposed to be yet, because I haven't figured out what we're supposed to get. I just want to get this random to give me something that's not a 0. Okay, now we get a -4. So now we're actually losing money. Ooh, that was -4. Yep, -4. Okay, because we were doing... Okay, then the actual, that's right. So then the actual is... Oh, uh-oh. That's why I did a bad thing. When we divide a number, that's an integer, by an integer, what do we get back out? We get an integer. So that's a logic error. Shoot. There we go. So divide that by a double, and we should get a double result. Right? So let's debug that one more time. This is why unit testing is great, right? We catch these errors easily. I don't have to try and look at my results in that little actual simulator to see what went wrong. And like I said, unit testing is actually like the harder part. We wrote the source piece here, the little simulator, right off the bat. But now we're unit testing and making sure we're getting correct results as we're going. All right, so let's see. We're going to apply return on investment. Let's step in. And let's take a peek. So what is it yelling at me about? Why is it a green line? Oh, it's not telling me right now. That's all right. So -4 is the random return. And then we should, oh, we still get 0. Why is it still 0? Oh, -4 plus 4. Oh, I picked a bad one again. Okay, so -4 is no good. Let's go back to something else. Oh dear. Oh dear. That's why. Okay, so we want something that's not a -4 because that gives me no return on investment. Let's try this one. This is irritating, I'm sorry. Let's give this one a shot. So we want not a minus. Let's see what we get. All right, we'll step in. Let's see what we get here. Okay, 0. So now 4 plus 0 divided by 100 is 4%. There we go. Finally. Now we apply, and if we earn a 4% return, we should get back $4. So now I'm going to change my expected here to 104 and cheat, because I know what it should be if I give it that seed value. Right? And what happens is every time I run it now, that should work, because we've seeded it and I know what the random value is going to be. So we're just kind of cheating, passing it a seed value. Let's give it a peek. It's running. And it passed. Look at that. And it should pass every time we run it now because it's fixed. Before, it might have passed like 1 out of 12 times when we randomly got that correct percentage, right? As it was using the actual seed. All right, so we got all of our unit tests done. The last thing to do is actually try running this here and see if it gives me what we expect in this simulator portion. And I feel like it should, but we're running low on time here, so why don't we take a break? When we come back, we will actually run it, give it this an eyeball as well, because this is code we should check out. It's harder to test stuff in main, right? Because there's no class to really call and test and have expected. So this one we're just going to eyeball, but we know the classes we're interacting with are doing pretty good. Okay, so why don't we take a break? We'll come back in about 10 minutes or so, and we can go from there. So if you got questions, drop them off in chat, and I'll take a look at them when we get back. Time zoom at 33 or so ish, 7:33 ish. All right, I'll put some music back on. You might get some Spotify ads, sorry, but we'll do our best. All right, see you guys.
revolution. Once you strike the ground, you feel it moving with the revolution.
To you, so I can be close to you. It's really simple if you look at it that way. Time that we get by with money we don't know. Pockets empty, but ours are full anyway. Hey, playing like children, love like orange. You were too good for me, but I wanted you anyway. I always loved you over my head, even when you lived alone to make your parents mad. Say goodbye to your own life, turn the page, follow my bed. I don't care if loving you over my head. to me like breeze, running free, beautiful images everywhere. You take a picture of us kissing in cars, it makes my day 10 times better. Yeah, playing like children and love like orange ray. You were too good for me, but I wanted you anyway. I always loved you over my head, even when you lived alone to make your parents mad. Say goodbye to your old life, turn the page, follow my mind. I don't care if loving you over my head.
Let your love for knowledge push the boundaries of your education. Begin your journey during Oakland University's virtual graduate open house, October 19th through the 23rd. You'll explore 135 master's, doctoral, and certificate programs and meet faculty who are ready to push you to your highest achievement. Reserve your spot now at oakland.edu/grad/events.
Hi, I'm Michelle Obama. The people who know me know that I love to immerse myself in good conversation, to really go deep. And this summer, I decided to press record. The result is called the Michelle Obama Podcast. I just hope it's as fun and meaningful for you as it is for me. The Michelle Obama Podcast is a Spotify original podcast, and you can listen to the series for free right here on Spotify.
Presented by Salesforce.
It's time to get in the driver's seat with an auto loan from MSU Federal Credit Union. We offer flexible terms and rates as low as 2.49% APR for both new and used vehicles, with no application fees and no prepayment penalties. Buy a new car or refinance your existing car today and enjoy the difference of being an MSU FCU member. Visit msufcu.org or stop into one of our branch locations for more information. Federally insured by the NCUA.
I'm not that girl that I used to be. Sometime I'm more than words. I'm beyond what I once was. I don't believe in love. Hey, hey. If I want something, I got it. Hey, hey. Oh, baby, I don't need love me. Hey, hey. Cause I love I cannot buy it. Wasn't real with you, boy. Real, wasn't real with you, boy. You won't give me too much chances. I don't care if I am fancy brighter. Yeah, yeah, oh boy, I'm telling goodbye, yeah, yeah, oh boy, I'm telling goodbye. I'm not that girl that I used to be. Sometime I'm more than words. I'm beyond what I once was. I don't believe in love. Hey, hey. If I want something, I got it. Hey, hey. Oh, baby, I don't need love me. Hey, hey. Cause I love I cannot buy it. Wasn't real with you, boy. Real, wasn't real with you, boy. You won't give me too much chances. I don't care if I am fancy brighter. Yeah, yeah, oh boy, I'm telling you.
Hey everybody, welcome back. Sorry about some of those Spotify ads. I don't know. It's what it is, I guess. Alright, so we left it off. We had all of our unit testing done. The last thing we want to do is actually run the simulator portion that uses those classes and see if they work. Right? Let's give it a shot. So let's go and run. Alright, so we don't want this to run forever. So let's just say, like, hey, we're already 50 years old, and let's say we want to retire at 60. So it's only going to run a couple times. Let's say we've got like $100 in our pocket, $1,000 in our savings, and $10,000 in investments. Okay. Look at that. We already made 3% there. Oh, we didn't make any money in our bank savings. We probably should set that. Well, there's one bug. Okay. So when we make our savings account here, let's go and set that interest rate. So savings.set interest rate. And, you know, let's go with 0.01. Just for 1%. Nothing great. Okay, let's run that again. So right off the bat, we found one error. That's good. Good to see. Excuse me. I'm going to refill my coffee cup here. All right, we'll pretend we're 50. I'm nowhere near 50, by the way. 60, $100, $1,000, $10,000. Right, and this time we got 7%. Look at that. So, and that's a good sign, right? Each time we run it, we should get different random values because we're seeding it with that time value. So it ensures we get a different number in seed every time the program runs because it's clock time in milliseconds since 1970 or something like that. There's this terrible bad day coming up in the future when that is no longer a 16-bit number. But that's okay. We don't have to worry about that for quite a while. Quite a while. It's the Unix epoch or something like that. That's worth Googling. Unix. Come on. Epoch. Epic. Epic? Epoch? Yeah. Number of seconds that have elapsed since January 1st, 1970. Not counting leap seconds. Oh boy. So, and then there's like the overflow. What is that day? Yeah, 2038. So we still have a while, for a 32-bit number, not to fit there anymore. So we got quite a while till that no longer fits to fix that problem. That's like the Y2K bug all over again. Were you guys even born before that was an issue? No, that's okay. Yeah. All right. So, going so far, we made some money, and sure, money in our pocket. We'll just put zeros. I'm just gonna do a bunch of zeros. All right, and we'll just see what happens throughout. Ah! Uh-oh. Oh man, went too far. Went too far. We lost the end of it. I'm sorry. I got too excited entering zeros. I only need 30 zeros, right, if we're doing it for 10 years. Or maybe 9, right? So 50 to 60, 100, 1,000, 10,000. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Done. There we go. Okay, so total savings here, 15,592. So after 10 years, this went up about 50-something percent. It's not too shabby, right? Our bank went up about 10 and a little bit extra percent for 1% per year. Like that extra additional didn't give you a whole lot here. But adjusted for inflation, only about $12,000 worth. So we're still ahead, but not as ahead as it looks. Right? You guys okay so far? And I think we're okay now, right? Any other questions on Project 2? Let me commit this for you guys out there to GitHub. Again, chat's awfully quiet. I'm going to take that as things are going great, but I know that's not always the case, so you've got to let me know if something's not good, because I have no clue. Project 2. Commit and push. All good. Awesome. Thank you for letting me know. I usually, like, people get sick. I look at people and make them smile and nod. Like, okay, smile and nod, please. Yes, yes. Smile and nod. It's painfully awkward sometimes, but I like the smile and nod. Yep, yep. Okay, and push. And ooh, and all of my unit tests should run out in Azure DevOps as well, right? Because we hooked that up. That was a fun little project to get our continuous integration testing running. All right, that one's done. So now let's make a new project. We are on chapter, why did I have to go look at this again? I don't even remember the number. Chapter 8, hooray, chapter 8. This is chapter 8, arrays and vectors. All right, there's a bunch of stuff here in the text, and I'm not a fan of all of it, but that's okay. There's things you might run into, so it's good to be aware of some of these techniques, but I'm not going to advocate that they're always the right or best things to do. So don't worry too much about it. And we'll make a source file, and we'll include our IO stream, use our namespace, standard, int main, eventually return a 0. All right, cool. So what we've done so far is we have worked with variables. We've passed them around inside of functions. We've written classes that represent nouns. We looked briefly at structs, which are kind of like classes, but usually use them for simpler things and not as much logic necessarily in a struct. But we haven't really had a way to deal with multiple values at a time. Right, when we said like, hey, first number, second number, third number, fourth number, they're all individual values. And that's really irritating if you want to store a bunch of values. Right? So let's say we were going to do some sort of lotto simulator, right? Like the daily 4 lotto. Right? We might say I want an int for numbers in the lotto, and I know I'm going to have 4 numbers. So what I got to do is this square brace notation tells C++ to go out and save space in memory for 4 integers consecutively. So there's this really cool thing that happens, and I think the other screen capture thing didn't work very well, so I'm just going to do it here in Word. Let's see. Let's try this. So when before we said like int, I don't know, number. Remember, C++ would go out and ask the operating system for some space in memory. And it was like x2, 3, f, b, or something terrible like that. We use hexadecimal notation. So letters A through F are included in that. And it would say, okay, here's where you can store, what is it, 4 bytes for an integer? Right, 32 bits, so a 4 byte. And it would give you this much space to go store that number. And you get all those zeros and ones, 0, 0, 1, 0, 0, whatever, right? A bunch of stuff out in this location. That's what we've been doing. Does this ring bells for people? Do we draw this initially? Where C++ asks for memory? If it's new, let me know. Sorry, that little bit of delay is annoying. I think it's only like a 5-second delay, but then you guys have to type stuff in chat. I'm going to assume it's not new because no one's saying it's not, and we'll go from there. So what we do is if we say we want an int faint bells, okay, good. Faint bells is enough. And we'll say this is like lotto or something, L-O-T-T-O. Sorry, my handwriting is terrible. It's no better than on a whiteboard than it is on my monitor here. And I say 4, those are square braces, by the way. That is terrible. Okay, I'm a little embarrassed now. 4. What C++ does is says, okay, let me go find some place in memory, like x3, 7, f, I don't know. And it gives you a space with size for 4 integers. So here's one int, here's another int, here's another int, and here's another int. So it is that much memory through the end of this one over here. Space is reserved for 4 different integers. And now what happens is we can now reference them using this. This is called an array. There's an array of values. We can reference them by index notation. So the first value here is at index 0, index 1, index 2, and index 3. And now that I've said everything starts with 0, maybe it makes sense why your first project was called Project 0. Just a silly programmer joke. It's not even a joke, a reference to it, sure. So I can get individual numbers out by index location. So I can say, okay, sure. So let's do that. Let's include C standard lib, and we'll include ctime, and we'll get some random numbers. So I'm going to say numbers array index of 0 is random or rand mod 10. And I'm going to do this 4 times. And you might think to yourself, why not just do a loop? Yes, I love what you're thinking here. I love you wanted to use a loop here. So I'm going to declare an int for number of numbers. I don't know. Size of numbers. I think size is usually more appropriate. Size of numbers is 4. And I'm going to throw that in here. And then I can do a loop. And I can say for int index is 0. Index is less than size of numbers. Size of numbers index plus plus. I love that you guys all went right to loops because we do not want to repeat our code, right? So index of index, boom. We now have some random numbers. Oh, a red line. Oh, C++. The expression must have a constant value because what happens is this needs to be known at compile time. These need to be declared as constants that don't change. So I need to declare it as a constant value here. So then typically it'd be like size of numbers or something like that as a constant value. So I know what the size is, but I have a variable for it because I want to use that inside of a loop later. You want to avoid having those magic numbers where, like, if you just have the number 4 in here, then you have the number 4 over here, and another time you have a number 4, and another time you have a number 4. They're magic numbers. You don't know what the 4 actually means, right? Declaring a variable and giving it a name makes it no longer magic. Because now you know what it is. It's the size of numbers here. All right, so now the numbers here, and you know what, we should rename this one too. Let's call this the winning lotto numbers. Right, is 4 random numbers between 0 and 9. Because I'm mod 10, right? So 0 through 9 are possible options, and that's how the lotto works there. Okay, so we get at them by index notation. And the reason we do that behind the scenes, there's a little bit of math tidbit here, is C++ knows that an integer is 4 bytes, right? 4 bytes. So if we say lotto index of, say, 3, I'm sorry, I'm going to leave that there. Let me leave that size 4, semicolon. That declares it. I could say lotto index of 3, and what it's going to do, it's going to take this memory address, and it's going to add, let me scroll down a little bit here. It's going to add in there 3 times 4 bytes. Because it knows an integer is 4 bytes, right? 3 times 4 bytes. So it's going to take this memory address, do some quick arithmetic, and get, oh, you want the one right here. So that's why we're 0-based, because if I say 0, you get the starting address. You get the first 4 bytes right here. If you say 1, you get the starting address plus 4, which is this one here. If you say 2, right, you get this one here. 3, you get this one here. So we can jump right to it. We get instant access through basic arithmetic. I know the size of the thing I'm storing here. Boom, done. I can get right to it. So that's how that index notation works. Right, the other thing we can do, there's a really cool enhanced loop. We're going to say int number colon winning lotto numbers. We're going to see out number and a space between them, no end lines, and then we'll say see out winning numbers, no end line, right? Because we want it all be on one line, and then we'll see out the end line. Okay, so this is called an enhanced for loop. We're saying for this is the type, and here's the variable name for it, of things in this collection, winning lotto numbers. This is becoming more and more common. People like using these a lot. I like them. Otherwise, you have to do this index notation and say, okay, winning lotto number index of. So it's the same thing as doing this, but we weren't assigning at this point. We're just using the value. So there's 2 different ways that you can loop through. You can loop through with index notation, which is still very common. People do this all the time. Or you can do this enhanced loop this way. Okay, so let's see if we can get some random numbers. Let's run. Sorry, I always want to right-click run. That's the wrong button. All right, so today's winning numbers, 1740. And if we do it again, winning numbers, 1740. Oh, we didn't seed random. Oops, okay, so srand time is 0. Semicolon. Now we should get some actual random numbers for the lotto. Look at that, 5730. Let's do it again. 4140. Awesome. Cool. So let's put this in debug mode. Right? Click in the gray area over here and hit launch with debugger, or local Windows debugger. And we're going to see what happens. Now, index has not been initialized, so it's garbage. We know what size of numbers is, and we know winning lotto numbers here has garbage values because we haven't initialized anything. It's just whatever's in memory. So now we're going to see each one gets assigned at a time. So you can expand an array here in debug mode to see what's inside of that array. Isn't that fantastic? And what we get, this is the memory address here, this X0137F7C8. That's where it's storing it in memory, in my computer's memory. So that times 0, or time plus 0 times 4 bytes is here. That plus 1 times 4 bytes is this number, and this number, and this number. We can figure out that arithmetic. Okay? Now, what some people might be tempted to do, right? And that's okay, right? So let's ask the user for some numbers now. We'll see out, enter your lotto picks. And sure, we'll just have them do it on that same line. Why not? They'll enter some lotto picks, so we need to see in. So let's have the user numbers. That's an int array of user numbers. Size of numbers again. Size of numbers. Right, we've declared it using that same size because it's going to be the same size here. And then what I can do is I can see into user numbers, index of 0, user numbers index of 1, 2, 3, 4, on and on and on, right? I can do it that way. 1, 2, 3, 4, and let's just say I screwed this up because it's very likely things get screwed up here. So we'll input a bunch of numbers. Okay, and then let's copy this loop and we'll output your numbers just for fun. Your numbers, and then this is in the user's numbers here. Okay, let's try that. Okay, so we should get some winning numbers. Oh, we don't need the breakpoint there. We'll continue. Okay, enter our numbers. So let's just do 1, 2, 3, 4, 5 because we wanted 5 values. Oops. The stack around variable user numbers was corrupted. We tried to change something at this memory address. User's numbers plus 4 times the size of a byte, or 4 times the size of an integer. That is not a valid location inside of this array. Right? That's over here. We didn't ask C++ for that. Right? So a bad thing happened. That's a off by 1 error that are super common. If we put the wrong number in for an index, we get bad stuff. All right, so let's fix that. Let's fix that. Okay? Let's not do that. But now let's change our loop here just because we want some more illustrations. Let's say we want to use that index notation. So we'll say for int index. Again, people use I here all the time. I hate seeing I here. I'm just particular because it's an index, so call it index. Like, it doesn't take you any more typing. And the reason I hate I's so much is that, you know how you can put a loop inside of a loop? Sometimes people will use I and then they'll use J. And they'll have an I index and they'll have a J index. And I's and J's look almost the same to me. And I get so confused. So I always discourage that. And just type it. It's not hard to type it. Size of numbers, index plus plus. And let's purposely here screw up again. Right? We're doing that. That's okay. We're going to take user's number at index. So when you see these square braces, usually I'll pronounce them as at, because it's at a given index. So user's numbers at index 0, at index 1, at index 2, index 3, on and on and on and on. right? Other people might call them other things, but I call it an at. Let's give it a run. All right, so let's do 1, 2, 3, 4, and it didn't crash. Right? It gave me 1, 2, 3, 4 garbage. There's no crashing when we tried to get an invalid index. C++ is like, oh sure, you want that? Go for it. Have it there. Now it's warning me that something bad could have happened here. I'm getting a nice little warning, just a green, uh-oh. It knows it's out of bounds. Like Visual Studio is smart enough at this point to warn people they did a dumb thing, which is nice. Occasionally. It's not perfect, but they try here. So you can never use less than or equal to size. You always have to be less than size. Okay? Because less than size will get you the right number of indexes. Because if you're size 4, you have indexes 0, 1, 2, and 3. 4 indexes, because we're always 0-based. So that's the biggest problem people run into when using arrays, is learning that you start at 0 and you stop at size -1 is your last valid index. So again, let's give it a shot real quick. We'll have some fun. Maybe fun. Oh, there it goes. 1, 2, 3, 4. All right, your picks, everything worked great. Looks okay. We're happy. Hopefully that green line will go away in a minute. I don't know why it's still confused, but we ran. And it's a little funny. There we go. Now it goes away. Of course. So we probably actually want to not show the winning numbers until after. Right? And now hopefully you're thinking, oh, well, why are we doing the same thing twice? Sure, well, let's not do that same thing twice. Let's make a function. I love the way you guys think. Let's make a little function here for print lotto numbers. That takes an int array called numbers. Uh-oh. Did I do it on the wrong side? I did it on the wrong side, didn't I? The numbers over here. There we go. Yep. Did that on the wrong side. Sorry. And you know what? Actually, we probably also want a string here for a message. So maybe we'll include string. Sometimes you need to do it and sometimes you don't. And I don't know, for the life of me, haven't figured out why. Like it recognizes string. Usually you don't have to import it, but sometimes you need to include it. So sure. All right, so instead of printing your numbers and winning numbers, we're going to do this thing here. Cut that, put it in here. So we're going to see out the message. Not in quotes, right? Output the message. And then for number in numbers, let's loop through and print out the number. Uh-oh. Is it unhappy with us? It's unhappy with us. There's a suitable begin function. None was found. That's a weird error. That is a weird error. I'm double thinking myself now. Wow, this was supposed to work. All right, we don't need the end lines, so then we were just going to call print lotto ticket. Print lotto numbers. We'll have like winning numbers, and then we'll pass it the winning lotto numbers, and then we'll print lotto numbers, and we'll print your numbers and the user numbers. Why is that unhappy? Is it not going to build? I think it's not going to build. Oh, look at that. Look at that. Oof. That's all sorts of errors. All sorts of errors. All right, I got to go back. I'm sorry. And look, that is definitely not working. Arrays, arrays, arrays. Passing the array. Ah, that's right, that's right. So because this is actually dumb and it doesn't know what size this is, we're running into trouble. So we need to pass an int for size, and then we'll do this index notation. We'll say for int index is 0, index is less than size, index plus plus. There we go. And we'll take numbers at index here, and we'll output it. Now it should like it, but we just need to tell it size now. So we need to pass size of numbers. And this is annoying. Size. Not fond of arrays in C++, by the way. That's okay. We'll talk about them because they're used a lot of places, and then we'll look at something better. All right, so 1, 2, 3, 4, 5, or 1, 2, 3, 4. Winning numbers, your numbers. Look at that, we did. Oh, maybe we want to print an endl at the end. So we'll see out and endl. Okay. One more time just to make sure it's pretty. Now let's see if we can guess the lotto numbers. Do you think we can get it right? We got a 1 in 10,000 chance. Maybe we'll get lucky. How about 1, 2, 3, 4? Oh, got it wrong again. Bummer. I think we're going to lose money at the lottery. Okay, so those are arrays. So you have to have constant sizes so C++ knows how big they are. Okay, you guys all right so far? So this notation here might also be known as a subscript notation. I just like calling it at, but that's just me. Yep, you can loop through. Sure. It's not so great at bounds checking, right? They'll crash, or sometimes they'll just get garbage values. Those are off by 1 errors. Ooh, a nice way of initializing here, numbers, if you know what's going to be in your array. So we'll let's just have an int of, say, I don't know, this is a example lotto numbers equals, and right off the, I'm sorry, square braces, to tell it it's an array, we can assign, using curly braces, we can assign it some values like 1, 2, 3, 4. And here, C++ is smart enough to know, oh, there's 4 things here, I'm going to plug in a 4. You can put in the 4 if you want, you can put in that constant value if you want, but it is optional at that point because it knows that it's only getting 4 values. Yes, so once you create an array of a given size, it's stuck at that size, and you cannot change it, Kitty. That's correct. So they're fixed size arrays, you can't change them. So this notation is pretty common if you're hard coding an array. This is a hard coded array initializer. Or, you know, even maybe not even hard coded, right? Maybe we input 4 numbers, right? So instead of saying, hey, user numbers size, and then we input 1, 2, 3, 4, you could flip it, and we could have int, you know, number 1, user number 1, int user number 2, on and on and on, and then you could pass user number 1 as one of these. So not necessarily hard coded, but like saying this is what the value is. So maybe hard coded was the wrong thing. Like initializing it with preset values. Initialize with values. How about that? Right, so we could have int number 1 and C in that, and int number 2 and C in that, and int number 3 and C in that, and on and on and on. It will give you the exact same thing when we're done. Right, either size it and set, or ask for them and then set. It's just a preference. Right, so we'll set that as 1, on and on and on. You know, why don't we'll just finish. 2, 3, 4. 2, 3, 4. 4, 3, 2. 1, 2, 3, and 4. 3, 2. Okay, so we can do the same thing there. And we can print the example numbers. So print lotto numbers, example numbers, with the example lotto numbers and the size of numbers. Size. Okay. How's that? So we should just get some example numbers out. One, 2, 3, 4. Look at that. We picked the example. So maybe we're going to add a function now for, like, did we win money? And maybe that returns an integer. Like the lotto, you can win $5,000 on the daily 4, right, if you match, right? Because they take half your money. Because it's a 1 in 10,000 chance of winning, and you pay $1. So if you buy 10,000 tickets, one of them will win, but you only win half of what you spent. Right? The lotto's job is to take money from people. And that's okay. So we'll have a check winning here that takes an int for numbers. We'll call it the winning numbers array, and an int for an int array of your numbers or other numbers. I don't know, other numbers, and the int for size. Okay. Now what we can't do, we can't say does winning numbers equal other numbers. This is no good. Right? If winning numbers equals other numbers, we'll return $5,000. That's no good. Sorry, that should be inside of curly braces, so don't yell at myself later. This is no good, because what this comparison is going to do is say, do you start at the same memory address? Right, that's all it does. This checks if we start the same memory address. Memory address. That's like literally, are you pointed at the same location? Okay, this is not a good check. So what we need to do instead is we need to check each value. So I'm going to assume that, let's see, let's do that. So we'll say for int index 0, index is less than size, index plus plus. Let's loop through both and check. So we're going to say if winning numbers at index does not equal other numbers at index, we can return a false. We don't match, or I'm sorry, return 0. You won $0 because you didn't match. And this is only checking for the straight win here. There's other ways of winning at the lottery that I just don't understand. I looked it up. I gave this assignment to a different class, and it was just nuts. Like the number of different ways you can win, and it's crazy. Right, so if they don't match, you immediately won $0. If we get through this loop and we haven't hit a return, means our code hasn't stopped, then I can return 5,000. Right, so if we get here, it means they all matched. Right? Because this was never true, so this code never ran. And that was it. We're just going to loop through both. So to check if two arrays are equal, you need to check each individual value inside of them. Check first and first, second and second, third and third, third and fourth, on and on and on, right? By index. And we always go less than the number of values in it because there's no index at that last location. The book says some people might oversize their array. So if you know you need 4 numbers, they might put in 5 so that you have access to index 1, 2, 3, and 4. I've never seen anyone do that before in my life. But sure, if you want to, go for it. I mean, memory's cheap. We can ignore that very first one in index 0 if it makes you happy. Yeah, I don't care. Sizing, yep. Initializing, yep. Looping, yep, that's fine. Enhanced loop, yep. Loop, yep. Okay, yep. Decrements, copying. So if you want to copy 2 arrays, right, you've got to copy them out one at a time. You don't want to say this array equals the other array. Bad stuff will happen there too. So let's see if this works. Let's see out U1, and we'll put a $sign in there, and we'll pass it the 2 numbers, right? So let's check winnings. Check winnings. We'll pass it the winning numbers. We'll pass it the user numbers, and then we'll pass it the size of there we go, size of numbers, and an endl. So that got a little bit long off the screen there. Let's bump that down. Okay, let's see if we win. And then let's do it again here because we're probably not going to win. Let's pass the example auto numbers. We'll compare ours to the example because I've hard coded those in. I know it's 1, 2, 3, 4. So we should be able to see, yeah, I do win eventually, right? To make sure that our function is, we're testing it here. Let's give it a shot. Excuse me. All right, so we'll go 1, 2, 3, 4. Look at that, we won $0, and then we won. We hit the jackpot when we match our numbers perfectly. Pretty cool. So let's try one more here. Let's, for fun, let's have an int array. This is another example. array equals the example allotted number. So let's do this. Let's assign one array to another. Can't even do it. Right? No good. We can't copy that way. It's no good. Okay, so we can't even do that. All right, so that's arrays. Let's see. Other things you can do, right? You can loop through them, find the biggest, find the smallest, find the average, that sort of thing. Another option, because arrays are fixed in size and we can't make them bigger or smaller, this is a terrible habit, we have better ways of doing it, but you can make the array oversized, and then you can only fill up to as many as you want. So if I don't know how many values you're going to put in, maybe I'll size it at 2000 and let you put in as many as you want, and then I'll use something called like a sentinel value, like we do with our loops to make it stop, to say, hey, once you find this value, this is the end of the actual data. It's terrible. I think that's a horrible way to do things, but you can. That's okay. There's lots of options, lots of ways you can do things. And it actually turns out we do a similar sort of thing with the primitive C string. So not our string class, but a different type called a C string that harkens back to the actual C programming language, not C++. So C++ is object-oriented, C is not. So a C string is an array of characters that ends with a special terminating value. It's the null terminator or something like that. I'm not going to use C strings or ask you to. You can. They're still in use today, but we have better ways of doing them now. And then the book gives you another suggestion, which I think is terrible. It calls them parallel arrays, where you need to store maybe like a list of names and their associated score. Right? So if I know I'm going to be adding grades for people, I'll put one array of strings and one array of scores, and we'll know when the indexes match, it's that person's score. That's a bad way to do things. You can, but it's just bad. The better way of doing that is you make an array of like a struct or an array of a class. Structs are good at that sort of thing. If you don't need additional functionality, you're just storing a bunch of data. You make a struct, hey, it's a string for name, it's a int for score, or a double for score, whatever you want to do, and sure. And then you have an array of type struct. So they don't all have to be integer arrays. Right? You can make arrays of any given type. So if we wanted to add a little struct here for that, like struct, I don't know, we'll call it grade. Why not? We'll have a string for name and a double for score. Right? Great. I can now make a struct of grades, or I'm sorry, an array of grades. So I can be a type of, uppercase G, grade. Excuse me. So a grade, call it grades, array of size, I don't know, let's do 10, right? Right, and now I can say grades at index 0 dot name and dot score. Right, we get at them just as if it were a struct. I just use this array notation to say, give me the first item at index 0. Give me the next item at index whatever. The next item at index whatever. The next item at index whatever. So that's the much better way. So do this instead of parallel arrays. Parallel arrays. Sure. Okay, and what happens here is C++ knows how big a struct is because it knows it's the size of a string and the size of a score. Right? It knows how much memory a single struct will take up, and it does that exact same thing with the arithmetic to say instead of being 4 bytes, it's whatever the size of that struct is. Another thing they suggest, and I don't think this is popular, but I'm not 100% certain on this, so I won't trash it quite as bad, is using this type def statement. I think it's terrible because you might as well just do a struct. But you can create an alias using typedef to say, hey, it really is this sort of thing. And I just find that more confusing, and they said it makes it easier to read, and I just don't understand why they would say that. So I'm not going to ask you to do it, but you can use typedef if you want. And sure. So passing arrays, modifying arrays. When you pass an array to a function, you are able to modify it. because you have the reference to the array. So if you want people to not modify it, again, you can use that constant keyword that we've seen. So just be careful when you're passing arrays, because we pass them by reference, not by value. So we're not giving a copy, we're giving them the reference, which hopefully makes sense because you give them, hey, here's where the array starts, and then they use that index notation to chunk along and grab different values out. There's also such a thing as two-dimensional arrays. I'm not going to have you do it in arrays because it's terrible with arrays. We're going to look at the better object in just a little bit here after we take our break. But you would use a square brace and a square brace. So some crazy two-dimensional array. So it'd be an int two-dimensional is square brace. And again, we'd give it size and size. So I don't know, like 5. And that doesn't have to be a square, right? So this is saying I have 5 rows. Each row has 10 columns. It's kind of how you read two dimensionals. Again, we'll get more into that once we use the better type, because arrays are terrible. But this is the number of rows, and each one of those rows now has 10 columns. So what you're getting here when you say that is you get 5 arrays, each with 10 things here. 1, 2, 3, 4, 5. Okay, so this is our 5 rows. So this is 0, 1, 2, 3, and 4, and each one of those has 10 values inside of it. Right? So any given value inside that array, so like that two-dimensional array of 3, 2, is row 3, column 2, right here. Does that make sense? You okay so far? We're good? All right, it's been a little while. Before we get to the next type here then, we're going to move on to vectors and finish that up. Do you guys want to take a break now, or do you want to talk about vectors and then take a break? And we're going to get into two-dimensional stuff here. That's row and column. Think of row and column. Totally up to you guys. Should I put it out in the Twitch poll? I'll do it a poll. Why not? Because someone said either way they're good. Let's do a new poll. Break now or later? Now, later, never. Just for fun. I want to see. So go ahead in Twitch chat there. Give me a vote. Take a break now, take a break later, never take a break. You just can't get enough code. I've been drinking a lot of coffee. This is pot number 2 for the day, so I am up for whatever. So I think I told you guys I've got 6 kids at home, and you know, for fun, my wife and I like to talk about baby names and, you know, what we might name the next kid. And I suggested the name Lance, and she said she doesn't really like it. Doesn't seem like it's a very common name. You know, not very many people use it anymore. And I said, well, you know, in medieval times they named kids Lance a lot. I didn't win that argument. That was a freebie there, by the way. Free dad joke. All right, so vote is 5 for never, 1 for later. No one wants a break now. Okay. All right, we will power through. All right, you guys are, you're having fun, I guess, then. All right, so arrays, sure, fine. I think they're terrible. You have to use constants. They're hard to deal with. You can do bad things, shoot yourself in the foot, yada, yada, yada. So the better thing to do is we're going to jump a little bit ahead here, but it's actually in the chapter, don't worry, to something out of the standard template library. The standard template library is your best friend because really smart people wrote all this stuff and we just get to use it. It's fantastic. So what we do is we say we want to include vector. I don't know why it's called a vector. I've never understood it, but it's a vector. It's like a smart array. The weird thing about it is it's got some interesting syntax, and we'll just get used to it. It's not a big deal. So to create a vector of, say, lotto numbers, we're going to say vector, and then we use these greater than less than signs to say the type of vector. So with arrays, we said, here's the type, and then we use square brace notation. With vector, it's greater than, less than signs. Sandwich in. It's a vector of type int. We're going to call vector lotto numbers. Okay? Then we can either put a semicolon in and be done. We get a default vector, or you can tell it how big you want it. Telling it how big you want it is totally optional, and that's the best thing about vectors. How big is optional. Because what you get to do now is you can take the vector lotto numbers, vector lotto numbers, and you can put dot here, and you can do stuff. It is a class in the standard template library. It has functions for pushback. Pushback means add to the end. So we can go get some other values, or we can just go add. Let's add a backwards one. How about we add a 9, and then we'll add an 8, and we'll add a 7, we'll add a 6. What you're probably thinking right now is, hey, it's not a fixed size, and you are correct. It is not a fixed size. Vectors are expandable. Technically, they're contractible, but that's a much more awkward, harder thing to do. So I like to only add to them. And there's ways we can get around it. It's just not anything we're going to cover now. I think when we get to the standard template library chapter, we'll look at something more interesting like that. But for now, right, we're just going to, just push back values. We can add them. So the better thing to do, if we know it has 4, we tell it 4. It's slightly more efficient. Pushback can be a little bit slow occasionally. Don't worry too much about the details. When you get to data structures, if you take that kind of algorithms analysis class, you can look at why that's good or bad. For us, we're just going to abuse it because it's fast enough here. We don't actually care at this point. And again, I'm kind of spoiled. I run all my applications on servers that have lots of processing power and lots of memory. If you're doing something on an embedded system in C++, yes, you're going to care about efficiency 100% because you don't have, it's not unlimited, but you don't have a ridiculous amount of processing power and memory. You want to optimize. I'm spoiled. I don't have to optimize. And again, we just don't necessarily have the time to get into that advanced level optimization. We're just trying to learn the language here. Okay, so our vector we can push back. Now what's cool is you can do that same sort of looping here. We get both options, right? I can say for int number in my vector lotto numbers. I can't type. We can see out the number and then a space. Right, and then when we're done with all that, we can see out our end line. Okay, or we can use index notation. So we can say for int index is 0, and here's the other amazing thing about vectors. You can say index is less than vector lotto number has a function you can call size. You can say, hey, what size are you, vector? And it will give you back the integer value of how many items it contains. It's phenomenal. Best thing ever about vector. So I don't have to deal with these constant numbers. I don't have to deal with those one-off errors. I don't have to deal with any of that crap because the vector will tell me how big it is. Right? I don't need to use constants. I don't need to remember, have those other things. Just say, vector, how big are you? And we can do our loop, which is the best thing. Index plus plus. And now, vectors do allow for the index notation like this, but it's frowned upon. So you might see people do it, but it's frowned upon. What we want to do is we want to use a function. So we say, I don't know why I copied that, vector lotto number dot, and it has a function called at. At is doing the exact same thing as this subscript array notation here, except at is safe. If I give it a number that is not valid, it doesn't let me do bad things and get garbage values out. So at is always preferred to the subscript notation. So we'll say at index. And turns out it sounds like we're pronouncing it the exact same way, right? You know, we say like array at index 0, array at index 1, array at index 2. It's the same thing. Vector at index, right? It's at. It's perfect. Oh, sorry. We weren't doing end lines. We were doing spaces, right? And then we were doing an end line. Okay, so either one works here. Right, we get the same enhanced notation, the quick loop, or we can do an index-based loop here. We should get out those same 9876 numbers. So I will always prefer vectors to arrays. Technically, they're slightly less efficient, and they take up a little bit more space. Again, I'm spoiled and I don't care, because I want to use them because they're easier. Boom, we get 9876, 9876. They work both ways. Okay, so this is fantastic. So, and you can initialize the same way, right? We could also initialize, we could take a vector of type int, another vector of lotto numbers, and we could, now we don't say equals though, we just right here in braces put the values, 9, 8, 7, 6. So the syntax is ever so slightly different. You don't say equals like we did with our other assigning ones right here. Slightly different syntax, and that's that'll throw you off. But if you try and say equals, right, it should. Does it not even warn us? It doesn't even warn us. Okay, maybe it likes it. Thought it didn't need it, but okay, maybe it's just a shortcut. So vectors can grow. We love pushback. They can use size. You can use pop back to remove the last item if you want. You can use clear to totally empty it all out. You can ask while it's not empty. Right? There's lots of fun things we can do with vectors. And the same thing, you could make a vector of a type. You can have a vector of type grades. Or grade, right? Grade. If you wanted. Perfectly fine with that. Int. Okay? So initializing objects, sure. Arrays of structs, yeah, we did that. All right, so let's look at two-dimensional vectors. And let's actually try and do something more fun with two-dimensional vectors. Sorry. What's beeping at me here? Oh, my sensor here. It's not telling me what my sugar is. It's probably a little high. I'm gonna at the next break. Oh, you guys voted for no breaks ever. I just gotta take a shot real quick then. The joys of being a type 1 diabetic. So they get for eating dinner. I forgot to take a shot with dinner. The high sugars aren't as bad. They just slowly kill me. The low sugars are the scary ones. They can make me pass out, which I've yet to do yet, which is nice in like 7 years of being a diabetic or so. Had a pretty good run. I actually saw a really cool post. I follow this science page or something like that on Facebook. They have all sorts of interesting facts every now and then. It said in the 1950s, it used to take 10,000 pig pancreases to generate a pound of insulin or something like that. And now it's all, like manufactured without pigs in a lab, which is super cool. And it's actually better, more efficient. And my body likes it much happier. Or my body's much happier with it. That sort of thing. Okay. All right, so two-dimensional vectors then. We would say I want a vector of type int with two different braces here. Right? That's that same notation here like this. So this is a two-dimensional vector. 2D vector. Okay? 2D vector. Then what I can do is I can size it here. Now I could, I think, give it some defaults in here, but it gets a little awkward. So I'm just going to do a little loop. So if I want, say, an 8x8, if I'm building a chessboard here. Actually, maybe let's do that type char. Let's do type char for character. So we'll say for int, this is row is 0, right? And I'm going to use nice values here because they mean things to me. And row is less than 8. Row push plus plus. I'm going to take my 2D vector and I'm going to push back a vector of type int. I'm sorry, of type char. Vector of char. Why is it unhappy with that? The vector push vector of char. Like that. There we go. Okay. Needs that curly brace or the parentheses. Man, not had enough coffee today. So I add an empty vector, and now I'm going to go add some characters. So now I'm going to say for int column is 0, column is less than 8, column plus plus. Let's take my 2D vector, 2D vector at row number, at row index, right? So it's going to be 0, right, for this outer loop. And then I'm going to push back, because that here is the vector I just created here. I'm going to push back, oh, let's see. So we want either a white or a black square, right? So the top left of a chessboard. Why am I not remembering this? I should remember. Chessboard. I think top left is a white square. Okay, so we want a white square. So the other funny thing when you deal with 2 dimensions, right? In math land, 0, 0 is down in the bottom left, right? Because you draw this nice little grid here and you say your origin is 0, 0. It doesn't work like that in C++ because the first row is the first thing you get. So typically 0, 0 is the top left here. And then, you know, size, or size minus 1 is down here in the bottom right. Okay? So let's see. So if we want a white square, I want a Unicode value for square. I want a Unicode character for square. Let's see if we can find it here. Let's try a white square. See if I can copy that. I think we can do it. Let's see. So let's push back a square. Okay, and that is if column mod 2 is 0. Right, so for even columns, right, and we're always 0 based, right? So let's look at that chessboard again. Let me just find a nice image of one. Just plain basic chessboard. Come on, can't be that hard. Here we go. Oh, that's. Hang on, we want to look at it from the other way around, though. Shoot. All right, now I'm confused because if we're the white pieces, the top left square is black, and that's usually how we look at it. So that one's backwards. Top left is white. That's not a chessboard. Huh. I'm really confused now. That's okay, I'll look at a real one. Right? So the queen is on her own color, this is good, so top left is white. So in odd, even columns, this column, this column, this column, this column. So column 0, column 2, 4, and 6 are white, and columns 1, 3, 5, and 7 are black on even numbered rows. Oof, okay. Does that make sense? So if the row is even and the column is even, it's white. If the row is odd and the column is odd, it's white. Okay, so if column is even and my row mod 2 is even, then I get a white square. If it's not, else I get, oops, a black square. So let's go back to those Unicode values. I think there's a solid square I can steal. How about that one? Let's try that. Just for fun. I want to see what happens. That's the solid square. Oops, cancel. What do they do here? Oops. Couldn't be saved. Ooh, shoot. Yes? I don't know what just happened. I probably didn't like some of those values. That's okay. We'll try it. Okay, and then when we're done, we want to print that vector out. Right, so we're going to use that enhanced for loop. We're going to say for vector of int row in my two-dimensional vector, 2D vector, right? Then I can say for character, I don't know, space, in the row. Right, I get two different loops going on here. What? No suitable user-defined conversion. Oh, vector of char. Yeah, vector of char. Okay, char is row, and each space is a char. Let's see out the space. Right, and we just smush them all together. And then when that's done, then we'll go down a line. End line. L semicolon. There. Let's see what we get. Let's give it a run. So 2 dimensions are fun. 2 dimensions are really fun. 1, 2, 3, 4. We want some money. Oh, they all came out as question marks. So we must not support those characters. Okay, okay, that's fine. So how about the white ones are just a space, and then the black ones are, what should we do for black? We just put an X. It's not as pretty, but that's okay. Let's try that. Did not like my characters. Now I'm feeling bad. That would have been really cool. Would have been really cool. Okay, 1, 2, 3, 4. Sure, sure, sure. Here we go. Oh, uh-oh. That's right, we were even, both even, or both odd. I forgot that or here. That's what happened. So it's either we're both even, or we're both odd. is 1 and 1. And it never hurts to explicitly add your order of operations here. I know that ands happen before ors, but never hurts to be explicit, right? Because the code's for us, not for the computer. Okay, so if we're both even or we're both odd, we must be a space. Otherwise we're white, otherwise we're black for our squares. One, two, three, four. We want some money. There we go. And look at that. We get our pretty little chessboard. I mean, it's not exactly, you know, it's close, right? You're not judging, are you? How's that feel? You okay so far? Maybe? So push back. So what we're doing here, when we create this vector, it's empty. So for every row, we need to add an empty row as that first dimension. Then once I have a row, I can start adding things to the row. So then the vector in that row, I can push back an individual character. So the 8 things in this first vector are vectors of characters. So what I have is I have 8 vectors of characters, and I can imagine each one of those as a row here, and each one of those rows then has those so many columns. If we're imagining things like that. Yeah, no problem. Yeah, please shout your questions out at me. Definitely need to answer questions. Do we want to add some like notes here? So this is adds an empty vector as the row, right? And this is adding to the row vector. Does that make sense? So we're adding as the row, and this is adding to the row. I think we could size it like with a vector of char or something like that. Size. I think you can do something like that, but it just gets kind of crazy. No, yeah, it doesn't like that. So like usually you can give vectors default sizes, but this is probably the easiest way to go about it. Just go throw them in there. So again, you can do the same thing with 2D arrays. Works the exact same way, but we don't get any of that, the nice, you know, I can add stuff as I want. So I always prefer vectors. I think they're just always easier to use. How are you guys feeling so far? If you push back a filled vector to a smaller size, does it remove the extra assigned information, or does it create an entirely new? So pushback will always add. So pushback is always adding a brand new thing to the end. That's why when we initially started, our 2D vector had no rows. This added the first row at index 0. So I could add already pre-filled vectors if I wanted, and you don't need them to be evenly sized. It could be what you might call jagged, two-dimensional, where each row is not the same number of columns. That's perfectly legal. Does that answer your question? Yeah, removing, there is pop back that will take the last thing off, or there's also clear, which will just take everything out. So pop back will remove the last thing. Yep, so you can remove the last. There's ways to remove from other locations, but that gets kind of nasty. So pop back is probably the way to go about it. Excuse me. Yeah, keep the questions coming, for sure. Yeah, so this one here is adding the empty row, and then here we're adding a character to that row. So we say 2D vector at row, we're getting the inner vector of characters, and we're pushing back those spaces or X's here as we go. No, because with a stack, you don't have access to any given index. With the vector, you can get at things by index, just like we could with an array. You get this direct access. So in the fact that you can only add or remove to the end, I guess you might say is a little bit similar, but you have access to everything in the vector all at once. You don't have to remove things and destroy it to get at the values. Yeah, and you'll learn more about stacks when you take the data structures class too. Those are fun. Yes, yeah, it's an array list in Java. Yep. Yeah, if you've done array lists in Java, that's a vector. Array list is actually a little bit fancier, I think. I think you can do more things with array lists, but it's essentially the same thing. That's a good question. Cool. All right, are you guys okay so far? I mean, you think you could try something on your own with these? Nobody's saying yes, but nobody's saying no. So I don't know if it's a good sign or a bad sign. Not so sure. Not sure what you guys are thinking. All right, so we'll go with the arrays, iffy on vectors. Yeah, definitely we got to play with them. That's what this next project's going to be for. Of course. I'm so glad you asked. So let me pull this up here. Just checking one thing first on a different screen, right? You guys don't see that? Good. Yep, so we've done projects. There were 10 points, 15 points. So let's make this next one worth a little bit more. And we can go from there. Cool. So let's add another project. New assignment. Let me bring this down here. A Schrodinger situation. You don't know until you try. This is project 3. So this will be worth 20 points or so. And let's assign this. I've got an existing grade item for you. Project 3. And okay, so here's my concern, I guess. I had said I kind of wanted this to be a little bit smaller, so you didn't have to worry about doing the project and the midterm here. And I don't think it's going to be huge. Okay, but if you guys object, I don't mind bumping it out a little bit longer. I could move project 4 to be here this week, and then it gives you 2 weeks for that one. Is that preferred, or would you rather just have it done and over with? I'm open to either. Or I could leave project 3, make it due this week, and still give you project 4 the midterm week. And then you'd have 3 weeks for that one and 3 weeks for this one, but there's some overlap and a midterm in the middle, which I'm feeling a little bad about now, but I promise it won't be terrible. I'm aiming for it to be short and sweet. What do you guys think? Should I just make it 3 weeks? And if you use it, you do, and if you get it done early, you get it done early? So we'll say like 11/4 at 6 p.m. I like that. So 11/4 at 6 p.m. 6 p.m. Look at that. Okay, I figured it out. Awesome. So we are going to, using 2D vectors, build a maze navigator program. Yeah, more time. Good, I like it. So we're not actually solving the maze ourselves here. So there are some things, and when we look at recursion, we'll look at how we can solve mazes in a naive sort of way. all we're doing here is we're going to take in data to build a maze, and then we're going to let the user navigate it themselves. Okay, so we need to ask the user for what size maze they want, and we want height and width. So it does not have to be square, but it must be a rectangle. I mentioned you could have those jagged things where not every row is the same size. Let's just, we'll assume it's a nice rectangle. Some height, some width. Right, so height is like rows, right? Rows, and width is columns. I don't know if that's easier wording. Can you guys read that? Sorry, that text is a little small. I think I can zoom. Not much before it gets funny, but how's a little zoom on that? Is that a little better? Okay, so we're going to create a vector of characters. Ask the user to input the maze. So in example maze, like for example, I might give you space x, 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 space x, like that. Oh, this is not going to line up very pretty here. Let me do it here in Visual Studio for you. So if I were to input a maze, I might have, again, I'm just showing you a string so you can see it here. It might be a space and an x and a space and an x and an x, x, x and a space. So spaces are open, you can walk in them. X's are walls, right? So then we'll have like a space, 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 x, x, no, where is it there? This is hard to see, sorry, the spacing is a little bit funny on it. There, and then maybe I'll have, you know, a bunch of walls here, and some walls over there. And one of these characters will be an S for start, and one of them will be an E for end. Call that end. So something like that. So imagine I have a maze like this, right? You know, sure, that's fine. So what we're going to do, the user's going to input a maze, something like that. I think I can put that back in. For example, I think I just need to change the, I can't even change the font though, can I? Sure. That's terrible. Terrible, terrible, terrible. Notepad. X. No, it still hates it. Okay. I'll just commit that in here. So this is a example maze, string example maze. Okay, something like that. And so they're going to enter that. They'll tell you the width, they'll tell you the height, or the number of rows and the number of columns, right? Height and width, number of rows, number of columns, and they'll enter a bunch of characters. S for start, X for wall, E for end. S for start, space, or a place you can walk. I don't know what you want to call that. A open space. X for wall. You can't walk on walls, right? And E for end. So they're just going to input a bunch of characters as characters. Okay. Then, and we're going to loop as long as the player has not gotten to the end. Allow them to move up, down, left, and right as desired, but don't let them walk on walls or out of bounds. If you try and go out of bounds and you don't prevent them, it will crash real hard. Okay, so we need to have some sort of logic that makes sure you don't try and get to a negative index or a positive index that is beyond size. You know, it's equal to size or greater, right? Because size is not a valid index. Okay, as soon as they get to the end space, game over. And they get to the end space. And, you know, for fun, should we ask them if they want to play again? I don't really care too much. That's fine. Okay, so what we're going to want to do is you're going to want to build out some pieces with functions. Right, it's going to definitely help your life to have functions. It's possible to do it without, so I'm not going to like require you to use it, but I'm just telling you, yes, you're going to want to use functions. Otherwise, you're going to be pretty sad. Oh, I'm going to make that 20 points. What happened? Oh, because I think I set all the assignments to 10 initially. So I'll make this 20 points. I don't actually, is this worth 20 points? I promised you they'd get harder, or get worth more points. Get worth more points, sure. That's fine. So, okay, let's say we do need to create a maze class that has this 2D vector, and let's interact with it using methods or public functions in the maze class. Okay? Because that way, again, we're going to practice our classes. We never get to forget classes. So we're going to create a maze class that we can interact with public functions. So the maze class stores the 2D array, or 2D vector of characters as the map. It knows where the player is, right? The player location. So you're going to start at start, whatever index that is, right? So in our silly maze example, where to go here? We started at 0, 0. So like if you're talking about indexes, right? This is row 0, and I have column 0, 1, 2, 3, 4, 5, 6, 7, 8. Right? This is row 1, columns 0 through 8. Row 2, column 0 through 8. Row 3, column 0 through 8. Row 4, column 0 through 8. Remember that notation? Right? In top left is 0, 0 in our world, because that's the first row, and that row has as many indexes as we tell it. So I can make a really big maze, I can really make a really small maze. And if you guys are curious and want some fun to play with here, what is it? It is Nukebot maze? I want to say that's what it is. Yeah, so GitHub put out this really cool challenge that would ask you to solve a maze, but what you can do is you can get a generated maze from them. You can ask for a random maze here of a given size if you wanted here. And let's see, so let's get that mazebot. Oh shoot, how do we do that again? It's in here somewhere. Is that the link? Mazebot, random, I think that's it. It's been a little while since I tried this. Nope, shoot. Oh, where do we do it? README? No, 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 no. It's in here. It's in here. There we go. Yep. Here. So this will give us a random maze. Whoa! That's 100 by 100. Holy cow. But it's giving us character by character. Here's the map. That's a little ugly here. So let's size that down a bit here. So let's add in, let's do min size and max size. Sure. We'll throw that in here. Oops. There we go. So that's a 10 by 20 maze. That's some crazy looking stuff here. So here's the first row, right? Here's the next row. They use A and B for start and end, but you know, so if you want some examples here, right, you can go get theirs. Sure, that'll work. So I'll post that link in Discord for you guys for example mazes. If you are bored, I'll throw that out there for you guys. Okay, so that's a pretty cool resource there. Anyway, so we're going to have a class maze that has the map, it has the player location, and we interact, or we navigate the maze using public functions. Using public functions of the class. Okay? Does that make sense? How we're going to use that and have some functions there? I guess I do want you to use something there. Again, you could use more or less functions inside of it. Any way you guys want to tackle that is up to you. When I show you a solution in 3 weeks from now, I'll show you my way. But again, it's not the only way. It's definitely, there's an art to solving problems. It's not all science. Okay? So it'd be nice, but we just don't have the tools yet to like pull out a random maze, or later we might do some, we could read a file that has a maze and I could give you different maze files to play with, or we got options. But we haven't done a lot of file IO stuff yet. We will get there eventually, I believe. Yeah, on that week when it's due. That's funny. We'll talk about more file IO stuff. Okay? How are you guys feeling? So next week we'll talk about pointers, and then we'll do a midterm review. I'll give you a bunch of examples, sample type questions. And then the week after that, we'll have the midterm, and class will be shorter because I'm going to reserve 2 hours of it for you guys to do the midterm. Do you guys want to start at 6 and end at 8, or do you want to start at 8 and end at 10 for the day of the midterm? Now, I don't need you to take the midterm at that specific time, but you will have a 2-hour time limit for the midterm, so everyone gets the same amount of time on the midterm. Unlike the chapter quizzes, which you can open and close anytime you want, I want to make sure this is fair so everyone gets the same amount of time on the midterm. So we can do class before or after, and you don't have to take it right then. You can do it anytime during the day. I can even leave it open until like later. Yeah, you want class 6 to 8? We can do that. I have 1 vote. 1 vote, 2 votes. So they're currently winning there. Yeah, well, so you can take the exam anytime on 10/28. I'll open it up like at midnight. I'll even take it through like 6 in the morning the next day if you want. You take your 2 hours, but then we'll only have 2 hours of lecture content there. So that way I'm not taking up, giving you a test and making you sit for hours and hours and listen to me. Although hopefully the listening part's interesting, but we'll see. You don't have to vote on that and tell me in public. That can just be your opinion. And then we'll keep on going with our topics. So we'll talk about Project 4 that week as well. Oh, wow, we got a lot of things. Maybe I'll bump that one down. I don't know. We'll see. See how much time that takes. I don't expect Chapter 11 to take tons of time. There's a couple topics we need to hit, and then we can have a project about it. All right, you guys okay so far? Cool. So we've got our project. Let me throw it out here. So I need to add the rubric for you guys. Let's see. How did unit testing feel? Did you guys like that? I kind of want to give you some points for unit testing this stuff too. But without knowing what your functions are, it's hard for me to, that's okay. I'll ask you to unit test it. It's always good practice. It's a really good habit to get into. And that'll help bump up some of the points too, out of 20 points. Okay? So let's add a rubric. I'll do this and then we can call it a night. What do you guys think? You guys can go practice. Yeah, unit tests are fantastic. You're hopefully should be using them anywhere you work professionally. They are super useful and helpful. Missing and complete. Okay. And then this is custom points. So everything can be different. All right. That's zoomed in a little bit much. There we go. All right. So, oh man, I lost it here. Hang on. I lost all the things I said about what you had to do. Usually I do it on 2 separate pages. That's right. Let me attach this one for a second, and then I'll come back. I'm going to save it. And I'll come back and edit the rubric on a second page. There we go. There we go. So I'm going to edit. There we go. Okay, and then I'm going to edit the rubric in another page. Oh shoot. Okay. I will get there. I'm sorry. I can figure out tools. Let's build out that rubric, because I think last time I forgot to build one for you for the project 2, and no one told me until it was supposed to be due, and then it wasn't. Other tools, rubrics. There we go. Oh shoot! And I think I gave you the wrong one too. Hang on. I probably made this as a file submission again. I wish they would just respect my defaults, but I guess not. All right, so what you need to turn in is the GitHub URL again. So not a file, but a link. So submit a link to your code, your project in github.com. Okay, got it there. Gotta refresh. Sorry guys, I'll get there, I promise. Rubrics. Okay, it's loading. Loading ever so slowly. There we go, edit. This is the rubric for project 3. Hopefully I can rename it. Otherwise I'm going to be confused. There we go. Project 3. Okay. All right, so two things we have to do. A bunch of things we have to do. Snap that one over. So maze length and width can be set. Length and width are set by the user. 2 points for that. That one's nice and easy, right? And maze input from characters from the user will give you 4 points for that one. So if you don't want or can't figure that out and can't make it work, if you just hard code a maze, you only lose 4 points. Okay, all these things you earn the points as you get, as you ask for them. So, right, as you complete the objectives. So the maze class uses public functions to navigate the maze. So that one will be worth 6 points there. No, let's do 4 points because that's like up, down, left, right. 4 points there. And then let's say the maze class prevents going out of bounds and walking on walls for 2 more points there. Okay, we're at 12. And maze class unit tests for navigation. Let's do 4 more there. And, oh, is that it? Is that all I have? Because I also want you to test that one too. So maybe that'll just be 2 points for that one. That's fine. We'll make that 2 points. And then we'll have a maze class unit tests for out of bounds and wall walking. Does that make any sense what I'm trying to say there? Like you're testing that you can't walk on a wall and testing that you can't do that. So that's 2, 4, 8, 10, 14, 16. Oh, what happened to my points here? What did I do wrong? Okay, that's fine then. So that can be 4. That's 18 points. And then, what, game over? Game over when the user gets to the end. The end character. 2 points for that. I want to move that one up. So above unit testing. There we go. All right. Yeah. I'll put it over there. So setting the length and width, you get 2 points. Inputting the maze is 4 points there. The game actually loops until they get to the end, 2 more points. The maze class, you use public functions to navigate, up, down, left, right, that sort of thing, right? So up, down, left, right. You ask the user where they want to go. The maze class prevents you from walking out of bounds and walking on the walls. And then unit testing the navigation, up, down, left, right, and testing, making sure we don't go out of bounds and wall walking. Is that unit tests for preventing a user from going out of bounds and walking on walls? So like if you try and do it, it shouldn't actually move your character in the maze. Does that make sense? Like I'm imagining what you're going to have here when you do your maze is like you'll have like, I don't know, pick a letter, like B for Bob if you want, M for Mary. So pick something, and as they say up, down, left, right, you'll move that and put Bob there. And then if they go down, we'll move Bob and put Bob here. And if they go right, we'll move that and put Bob here. And if they go right again, we'll move that and put Bob here. Does that make sense? Like how they might move around the maze? So you're going to print the maze every time to show them where they are. And they can go up, down, left, right to navigate. But if Bob tries to go right, he shouldn't be able to go anywhere. He should just do nothing. Or we should tell them you can't go there. If he tries to go down, tell him he can't go there. Right? And ask, do you want to go up, down, left, or right? Does that make sense? So hopefully we've covered everything there. And let's see. So just some practice using the 2D mazes here. This is over. I wish I could get rid of that one there. Okay, does this one save automatically now? Close, I like it. Hopefully it saves. Let's see. Now let's check it out, make sure it's attached. I think it's all attached. Yep, cool, looking good. All right, any other questions before we wrap it up for the night? Get a little bit of extra time to get a head start on anything you want or practice, use some arrays, use some vectors. You're sick of me telling you, but I'd be walking around having you try this stuff on computers in the lab and seeing what's going on there. So try and reserve some time. I can hang out on Discord till 10 or so. If you have questions, hit me up. If not, find me anytime. Questions in Discord are strongly preferred because if you have a question about it, I'm sure someone else has a question about it. So if you ask in the class Discord about, hey, can you tell me more about this, or can you clarify this sort of thing, everyone gets the benefit of hearing it and seeing the answer, just as if you're asking a question in class. So go for that. Again, if you're not comfortable, that's fine. You can direct message me, call me, email me, text me, any sort of way you want to get a hold of me. I'm good. Oh, thanks, 404. Yes, there's the link to the Discord, and Heather. I appreciate that. Okay, and you can always post some hot memes. I think someone had done one. Did I miss that one? Where is it here? Yeah, that one's good. How do I have to save it? I'm going to bring that up without downloading the whole thing. Let's copy link. Is that it? Can I do that? There we go. That ought to do it. Refactor is a fancy word for like changing your code around. Test pass. I don't believe you. Deliberately break something just to be sure. Test pass. Uh-oh. Changes nothing. Tests fail. Oh no. Run tests and they pass. Oh, that's bad. Yeah. One of the good reasons, actually, that I really like test-driven development is it makes sure that your tests fail initially. Because believe it or not, that sort of thing happens where, like, you wrote the test and something's wrong with it and it's passing when it shouldn't pass. So when you actually try and break something, your tests still pass and you're really confused. Like, why is it doing this sort of thing? So having a failing test initially is actually super helpful because it's making sure that, yes, it's actually going to pass when it's supposed to pass. Or it will at least get you closer. I guess there's no strong guarantee there, but should get you closer. Okay? All right. Other questions, thoughts, concerns, issues, comments, memes you want me to share before we go? Cool. You guys are good. I know these night classes are rough. Hanging out for so many hours on end. Listening to me gets really boring, I admit. I mean, I'm bored of hearing myself talk, so more power to you guys. I'll have the recording up later in D2L. Like I usually export it to YouTube or watch it on Twitch or YouTube. Doesn't matter which one. Yeah, cool. So I think we're all set then. You guys are doing great. I'll get to grading your stuff. Apologize for being behind. Oh, you can check out the VOD, Valentino Pizzorno. I'm terrible with names, I'm sorry, especially on Twitch. Handles are even harder than real names. Yeah, all the VODs are available. You can check it out. So I'll call it a night. You guys take care. And I'll see you next week or sooner if you get in touch and reach out and let me know how it's going. All right, see you guys.